just like using using for web scraping, because like of course you can just do like web scraping through like raw HTTP requests, but then you're gonna get like blocked. Um, if you're not like using a browser, you know.
Right. Yeah.
So I don't know. Yeah, it's been a while since I've even been in that space. Um, but so okay, I need to. Oh my gosh, my I'm used to my environment being set up because I never turn off my computer, but I have had my computer turned off for like 3 days while I take a bit of a like a break or a I'm technically on vacation from work this week. Um, so I'm just trying to remember where my bearings are. Okay. I'll start sharing my screen. Oh, that's the opposite. Um, okay. So actually, I should start from here. Um, so the idea of this framework is like no matter how brand new to coding you are, that you can just kind of come in and get started with this very quickly. So this is the Jenga framework. Um, to get started, I just kind of like. I mean, I might make this a little bit more fancy in the future, just to make it better Git wise. But like, you would just come in, SSH into here, and do a Git clone of Jenga. Jenga already exists, so I'm just gonna call it Jenga 2. Um, and Jenga is it is literally just an obelisk project. So a lot of my documentation is going to be like I still have to build a documentation, but that will be focused around that. So for example, when we go into an obelisk project, we have a number of commands that we can do. Um, right? We could. This is kind of I guess useless to us at the moment because we already have our init by doing get clone. So that's something I might replace in the future. Um, deploy is well, actually we'll get to that eventually. Ob run is our kind of base command that we want to run our project, but we also have ob hoogle. So I should get this started. This is just a Hoogle server. It's going to have everything from our project that we are using installed. Um, and yeah, what we're gonna do today is we're gonna build a weather app. So I figure the best way to go about this is that um, we're first just gonna basically have a really simple what's the word I'm looking for? Just like a really simple setup. We're just gonna basically forward a request to some weather API. Um, what was the one I was looking at? Weather API. And then we're gonna eventually use WebSockets to get real-time updates about weather. Um, so what was I looking at here? Okay. I think I've already logged in. No, okay. I guess I need to sign up still. We need like hold music for this kind of situation. Oh my gosh. Why does it let me? Wait.
Oh, after
Okay.
that.
Yeah. Right. Uh.
Like you could do a check on the email before you even sent and just say this email's already in use. You didn't,
Right.
but you know what I mean?
Maybe I just never reset my. Already verified. Okay. I must have used another password. What the? Oh wait. Was it? Okay. I officially forgot my password. I don't even remember saying a password, but okay. Maybe they gave me a temporary password and I never used it. Okay. Um. Cool. So this is my API key. Now everyone has access to it. Um. I'll probably edit this part out of the video, but yeah, we don't have that many people on the call, anyways. Um, I don't think this can be abused. We'll see. Yeah, I guess they could just no. I don't care. So yeah, let's just start out by. I mean, I figure it would be a good idea to use API where we can. So I think this is a good example of a time to use AI because I have confidence that we'll be able to do this easily through ChatGPT. So we just want we want to basically generate this JSON response um, through Haskell. So can you do it in Haskell? Just because I know some people, especially in Haskell, like just don't like using AI. I don't either, but I do find sometimes it can be accurate for things that are more commonplace. What's it using? What is run request? Can you just use? This might get stupid quick, but worth a shot. Okay. Yeah, no, that's perfect. So let's start with that. Are we running Jenga? No, we're not. Let's go over here. Obi run dash V. So um, we are going to start by making this a new request. So actually, really, like the one of the I kind of jumped ahead of myself um, by getting into what the weather API will be doing. First, we're going to need to, of course, make a request from our own front end to our own back end. And that back end is going to be, what takes our API key and goes and performs the request. We could, of course, you know, there's not any real reason we couldn't do it from the front end except for the fact that we would expose our API key. Um, so we will do it that way. The way that we're going to want to do this, well, actually, I'll show this way first, is we have this request um, where it's basically this is how we are already doing um, our authentication, right? So this comes like pre-bundled with the Jenga framework. So we actually do have the ability to authenticate already. So for example, someone can sign up, and then we see it over here. Um, if we look at backend.hs, sorry, backend.hs, um, we can see that someone also has the ability to log in and reset their password. So I actually have two different ways of making a request through Jenga. The first on the right is through just like kind of normal HTTP. So that's what I've used it for login and reset password. Um, is because we need access to like raw HTTP. Whereas um, this form is done through WebSockets, like through a WebSocket channel, um, and it's like it's actually a lot easier to use. So um, so we're gonna use that, and so the way that we want to do this is we're gonna go to our common directory. We're gonna look at common.request. So common.request has a bunch of I'll just remove that. Has a bunch of like kind of presets, I guess. Again, with it being a framework, a lot of stuff just comes right out of the box. And you'll notice too, like if you're using the Django framework, that I have like a very particular way of doing my imports, which I kind of actually violated there. And that goes like the top is my like least trusted, and the bottom is my most trusted. So these are like from the actual like from my code base, right? Me as a Django user, it's from my code base. This is like kind of more progressive libraries that exist in Haskell. So, for example, Obelisk, Rhyolite, and Jenga, Lamarckian, which I'll get to. They all are imported in like in this region. And then everything that's like kind of very commonplace and used across like a million different libraries, I would have at the bottom here. Um, right, so ASON as a JSON library we use everywhere. I'm not sure what's going on with my computer right now, but maybe there we go. But yeah, so we have two gadgets, um, two gadgets to represent our requests. A gadget is a generalized algebraic data type, right? So literally gadget here. And what that means is that we have flexibility. We have just a bit more flexibility in terms of like our data constructors. So in theory, like this could be, let's say we like had a type where we didn't have this a, then there wouldn't really be any difference between um, this and like a normal data type declaration. But with this a, what this means is that this here can be an a. But then also that like like let's say names two or whatever, right? Or weather, private request weather. This can be something else, right? So we have more flexibility in terms of what this a can be. So we can either have a data constructor that contains, right, or holds or contains an a or a b. And when if we were to go and wrap this, right, if we had this at the value level, like private request, let's just say, yeah, rec weather, or I could just copy paste, that'd be easier. And we have x here, and x is an integer. Then we would say that the type of this data here is a private request int, right? So if this is an int, then the entire thing is an int. That's about like as complicated as the library or framework gets, um, and it's a necessary complication, I think, because it makes while some people are maybe afraid of gadgets, I think they're definitely like doable to learn and use. I think they're actually kind of intuitive in a sense. But anyways, so this is a request we have here set up. I'm not gonna use. I'm gonna use the public API for now, just because we're gonna set up authentication once we're done everything else. Um, so we're gonna say public request weather. Um, and I'm not sure what this is gonna take. I don't think for now this is just gonna take nothing. So I'm just gonna say public request either backend error, um, backend error. I mean, I could, to be clear, I could say anything here. So I could just say like weather response, but this is like kind of saying here that like there's no way that this fails. So I want to give a either backend error um, of something or a weather response. Yeah, that makes sense. Oh, I need mismatch brackets. So yeah, I want either a public to get either back an error or a weather response. So the first thing I should do is I should go and define a weather type, or sorry, a weather error, and this should throw an error because weather error is not defined. Neither is weather response. So I have a bunch of stuff I gotta purge here. Okay, so um, I'm gonna have a data weather error, and the options for this, I'm just gonna say for now that we had a bad request to API. Not really sure what that's gonna be yet. This is gonna be more errors. And a weather response. I'm just gonna say that a weather response is a weather response is I'm not really sure yet. So I'm just gonna put an empty thing there. I do that. Oh, I need to JSON because this is going to be sent over the wire through JSON. Oh, and it needs an instance of generic, so I can just say deriving generic, which basically just means that we can use what's a good way to describe generic? That feels important to talk about. Generic is basically just a way of getting more access to the details of the like of the language. Um, so for example, I could get like what the data constructor is that we use, or maybe even record fields is a more common use case. Generic is not in scope. Okay. And that comes from ghc.generics. And JSON of weather error. So we need instance to JSON, weather error, instance from JSON, weather error.
I don't know if this is entirely accurate, but I just always think what generic is it just tells the compiler to effectively look at the data type and construct the most common sense version of that in whatever you're trying to do. So for JSON, And obviously, if you've got record fields, it turns it into your normal JSON fields. But so if you're written it the way that you expect to see it in your code, the data that in your code, then it should just be able to use generic. If you want something more exotic, you'll have to do it yourself,
Right.
basically.
Like if I have, for example, some field here and it's an integer, we would expect that like the corresponding JSON that we get back out looks something like, you know, some field. Right. So we'd expect, it to just make it for us like that. And so generics is basically an overloaded way to do that. And we for example, we also use this for our database, which we'll get to. Um, and yeah, because we can derive database tables just based on like the format of our data declarations. But yeah, no, that was a good explanation, Nick. Um, how many types? 16 type. Oh, okay. No, this is for generic weather error. Oh, it just didn't save. Okay. Oh, and now we need like this is a this this is gonna feel silly, and it kind of is. I just I did this for myself, and then I was like, you know what? Like as simple as this is, I kind of love it. Um, oh, it's giving me for name error. Oh, okay. Well, I guess it's not really that big a deal if we do it for name error and weather error. It's this really simple class called specific error, and all specific error is basically forcing you to say that like this follows a pattern. Um, right, so I can do that. Specific error. I think I need Jenga common errors, right? Yes. Okay, so that worked. We're gonna get that error eventually for weather error once we actually do something with it. And all this basically says is that I can't use like text or like just use like a plain old text for my error. I have to say that I have an error which is wrapped in a backend, or we can wrap in a backend error, um, and it's something I've defined. Of course, you could just like, have a very silly error that like all it does is wrap a text. But even then, if you were to like wrap that error, it'd be much more information for when something goes wrong to track down like where that kind of happened and everything. Um, right. So like for example, I'll see this like kind of notification of like a user had a login error, and I of course like know that that has come directly from the login. And if I want to investigate and just kind of make sure everything has gone, there hasn't been a bug, I can easily do that. Instead of going on a rabbit, sorry, on a goose chase of where that error came from. Okay, so public request weather. So now this is saying that our backend is complaining because um, we have not handled all of the possible cases. So the reason for this is because I have enabled um, warn all. So warn all, warn error upgrades every single warning into an error. There might be some cases where like you find that's kind of like a little bit silly, maybe. I haven't really found one yet. Every single like every single warning I found in Haskell is actually like I wouldn't even consider it a warning. Like for example, the fact that I haven't done something here, um, that someone could just have like an exception if I don't handle this request here. It, that's not like that's more of an error warning, like a warning that an error will happen, than just being like a warning about like, oh, I don't like the way that you named your type. Um, right, because I've seen that in other languages where it's like you use the wrong naming convention, please rename it, and it's just kind of like not really important. Um, but yeah, so that's why we did that. Um, I think at the very least, like warn all what is this? Warn incomplete patterns is like the minimum of what you should have. Um, okay, so now we go to our API request public. So this is basically what this request handler is doing is it's going to get a request um, through through a, yeah, it's going to get a JSON request, JSON encoder request through the WebSocket that we've opened up, um, and so we just do that once. I could show you guys how that works, but it's not super interesting. What the heck, I will. Um, um, we basically we build we this is a very complex function to build basically a WebSocket environment, and then that gives us a function called handle listen, and then all we do is we have this route where someone can start up a backend connection, or sorry, a WebSocket connection with us if they call this route. So this backend route listen pertains to localhost 8000 slash listen. And so if we call that, we then plug into the entire WebSocket framework. Um, and so then that means that we can add another request here for weather. Right? So we can say, what happens if someone requests weather? And you'll see here that like for public request sign up, we have an email. But for public request weather, I believe we just didn't have any arguments whatsoever. And so I'm just gonna say, can I just say pure here? So this should fail. Um, this is why I like the WebSockets request better, is because if we look at this, why this is going to fail is because I have said that it returns an either backend error, weather error, or a weather response. So that means I need to say pure write weather response to make this satisfy. And that worked. That the types are happy. Um, right, so I know what type I have coming in. I know what type I have going out. And then I can, of course, do the work on the inside to figure that all out. Not that not that we're doing bad for time, but I'm going to start with the reflex aspect of this, and then get to the weather API because I feel like calling the API is almost one of the easier things to do. And we actually even already got AI to do it. Um, and APIs are of course like well documented, well usually very well documented. Um, so I'm sure that we could have an AI, help us with that. In any case, so now this is our front end. Um, how do we build? Yeah, I guess how do we build our front end is kind of an important question. Reflex is Reflex and I guess Obelisk therefore and therefore Jenga is a single page application. So um, what that means is that we're basically just like you know, we're swapping. We're still like we obviously still have many pages in a single page application, and that's because we're switching out the DOM, but keeping everything else loaded. So this this kind of functionality is going to run once, and then at that point we're just going to be switching over to through our app router to like kind of whatever it is that we are doing, or whatever page we have requested, right? So, for example, if I go to common source and now route instead of request, I can see that I have what is this, 5 front end routes, and I guess let's add one for let's add one for weather. So we're just gonna say front end route, um, show me weather, and this is just gonna be a front end route that we'll just say really takes no arguments. Um, so this is also a gadget, right? So instead of previously we had our a, right? We had our a, and I think this is actually valid syntax if I was to do this. Um, this is this is what we had before, right? Now we just have a little bit more information, a little bit more explicit declaration that this is a higher kinded um, type. So, um, what does that mean? I don't know. You know what? Actually, now that I see that, I'm kind of confused with regards to seeing this. But ultimately, I've never. Here's the thing: I've never really thought about this too much. Um, an easier way to think about this is that like it's still just a data constructor, which is which results in a front end route with a particular contained data type. And so I am choosing here what the data type is. So you can see here that I have like for the reset password route, I have a full like signed reset password or password reset token. Right, so that's a full on like data, um, full on data type that we have there um, as an argument to our route. And what that like actually evaluates to for like the example of front end route reset password is that I would have for reset password, I would have a way to decode it and encode it. So, okay, the wrong one here. So front end route reset password is basically is yeah the parser for that route is that we look for the reset. So we look for slash reset, and then we looked for a signed encoder. And do we have an example of that? Yeah, we do. So this gets a little bit more complex, um, but with Jenga framework, you kind of can avoid the you can avoid doing anything super complicated with the HTTP routing before you really need to. So I'm gonna ignore that for now. But basically, what that signed encoder is gonna look like is this massive, hash. That is our signed payload to say yes, you are the person that I sent a reset password link to, as we would have seen for myself in the Weather API. I would have gotten a link like that in my email, or no, I got a temporary password, but I could have. So I guess this setup avoids using a temporary password. And where is I? So yeah, so now we've added our front end route show weather, and so now we're just gonna say like, what does that actually look like for the user? That's our data type we defined. What does it look like for the user? And we're gonna say that it's a very plain route. This is just a function that I've added in here. Um, and it's basically well, it's not super interesting, so I'm gonna ignore it because I know that I talk about way too many things in every session. So I'm gonna try and avoid that. A plain route is basically just gonna allow us to have this slash weather API. Oh, and I gotta get rid of that because I haven't enabled some extension. Expected one more argument to show weather. Right. So this is expecting us to give a data type, and I'm not actually getting any data type, any data from the route itself. So and actually, here's a great example of this: is like a get request, right? So if we had like, for example, a query parameter, right, where we have like slash like weather, um, you know, city equals Waterloo or city equals Toronto, right? This would be an example of where we might want to get um, more customizable with these routes. But we're not even using this version, so we're just using the obelisk routing for our front end, and so that's everything we need to do. What's complaining here? Oh yeah, this is saying that in front end now we need to go and handle that case. So I'm gonna put this right at the top here. Front end route show weather. And this is just gonna be, what is this gonna do? I don't know. This doesn't have to do anything for now. Um, oh actually, this does need to. I mean, this is just the way I set it up. This is like subject to change. Um, if there's a better way, I guess. But every route needs to basically return if they changed an event of like if the auth environment changed. So our auth um, what 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 factors we have available for our auth are if we have like an actual auth token for them, so we have like proof that they've signed in, and we have a I get I'm not really proof. I don't consider it proof in the framework. That's a whole other story. But we have information about their user type. So a user type is basically just whether they are an admin user or not. Like I said, this is like Ace's old authentication setup for when we had a more complex user type. We're actually basically just moving to a very simple user type. That's part of why I wanted to build the Jenga framework. Is I'm like, we're gonna throw away a lot of this. Not gonna throw away a lot of this code, but like, um, you know, might as well use it somewhere. So we're just yeah, we are to satisfy this type constraint here. We have to end um, with basically returning an event of whether or not the auth changed. So for reflex, we have this kind of like what's it called? What's a good way of explaining this? We're gonna go to our local Hoogle and we're gonna ask like, what is the type of never? So never is an event, and it's just an event that never actually happens. Um, right. So an event is right something, but by nature something that happens. You can think of weather as kind of being an event. If we have, maybe we could have an event system that notifies us if it's ever going to rain. That because the event of rain or the rain would be an event. Um, but yeah, and so I have a type that represents that called event. Um, But there's going to be some cases where I need to return an event, but I never want that event to actually happen, right? I need this to type check, but I don't want this to ever actually happen. Um, yeah, and so like you might be if you're looking at this, you're seeing that like this is like a event maybe, right? So like what are we all able to do here? If we had something like if we had instead pure nothing, then pure nothing or sorry, this would be actually pure nothing um, on like a click event or post build, right? So post build is a event that fires when we are done setting up the DOM, right? What this would do is this would immediately just sign us out. Um, it would sign. It would remove the auth token, and that would be the end of us being signed in. We're not even signed in right now, so it doesn't really matter. But anyways, that is what we're gonna do. Is we're just gonna put pure never for now, so that the event never actually happens. Because we don't care about that currently. Okay, and so now we're just gonna have a um, very simple API. So what are we gonna do here? I guess it looks like we can easily change out what the location is. So I'm gonna actually have a location. Um, I'm gonna have location be a thing that we are going to plug into um, this API. So I'm gonna start by taking just this piece here, and I'm going to put this in common types. Right? I'm gonna put this in common types. We have our what's complaining? Oh, don't have data text. This is complaining because the auth or sorry because the import is not correct. I've imported text as a qualified T. I'll remove this version. Yeah, that looks better. GC generics. Um, I also have the other error, so the other warning of unused imports, raising as an error. This is kind of like a preference of mine. There's nothing wrong with disabling it. I think it's better to keep your code base clean, is why I have that. Okay, now 212. Oh, instance to JSON. So yeah, actually, continuing on with what we were talking about earlier about JSON, we can tell that this is going to, by using generic, it's clear for me to see that this is going to look like location is, Toronto or whatever. I'll say TO for short. And current is, what is current? Current is also going to be a contained data type of, temp C, right? And so on and so forth. I think we get the point there. Um, no instance of to JSON for current, right? So it's trying to build our JSON instance for weather response, but it sees that a contained data type does not have a way of doing does not have a way of performing that verb, right? So we do not have a way to go to JSON for location or for current. because the AI did not come up with it for us. So let's just quickly change that. Current. What the heck? No instance of two JSON for condition. Oh, I thought we did that. Okay. Condition. And WebSocket's request is now complaining. Because we moved that to a different file. So I'm going to say import common.types. And it's now complaining because it's actually a different type. Um, and yeah, it's not expecting. This is basically saying, like for reading the actual error, this is saying that you're trying to return into your API a function instead of this data type, which you've said it is. So that makes no sense for two reasons. One, we would never return a function, so this is just not fully applied, which we can see right by looking at our weather response. Weather response is a data constructor, therefore a function that takes two different arguments, and also the other error is that we have said in request that public request weather takes returns an either a backend error or a weather response. So let's go fix that. Um, and this is going to get annoying to try and do, so I'm going to say instead that this is for now, just an error. And I'll say left uh, left user error. Right, so we have two options. Actually, it'd be easier if I show it this way. B user error. This is a backend error. And we basically have the choice between saying this is a critical error and a user error. Um, did I? Oh, okay. Um, I am okay. I need to close one of these. Sorry. So this can be a user error here, and this is going to be a weather error. I think we just said that a weather error is like this. Or wait, what am I doing here? I'm going to say Jenga common errors is where that comes from. And a weather error, what was it? It was a bad API request. So this is the value you can return, and it is of the type weather error. Now we have well, for now, a minimally working um, handler. And so now what we're going to do is we are just going to pass, we're going to pass a location. So we're going to actually need to do one more change as well here, which is we're going to need to go to common. Common request, and we're going to pass location. What is a location? Does it make sense to reuse this type here? Yeah, we're gonna pass a location, as a argument to our request framework. So let's do this. Let's say this public request whether takes takes an argument of location and returns us a public request of either an error or a weather response. That's going to update. Is going to cause an error because we haven't pattern matched properly on the public request of weather, and so we're going to say location here, um, and now that's going to work. Oh, and we haven't used this yet, so I'm going to prefix it with an underscore just to say I know that we haven't used it yet. Um, but I still want to declare it. Okay, and now focusing on this, we're going to build. We're going to have user input for this location. So a location, I shouldn't have closed it. A location is a name and a country. So we're going to want to have two fields for a name and a country. So how do we? Oh man, it's been a while for Reflex, but it basically there's an input element. So we're going to use this input element. The types are a little bit overwhelming, but basically we build an input element with our input element config, and we get back an input element. Then from the input element, we're going to be able to extract the value. And that's how we're going to do this. So what is an input element config? We are going to say input element. This input element. I'm just going to say default config. So this config, I can see has a default. And default is just a very simple class that says I have a this type has a default value. So Reflex uses this all over the place, and we can just easily say input element default. This is usually how I actually go about things, and yeah. And now I guess I need two input elements. So I'll say that. Does that work for now? So I have two input elements. I'm also going to need. Let's call this the name. Oh, what's the name of the city? Maybe this is a AI hallucination. That feels weird, and this is AI code. So I don't know. We'll check back on that. I'm gonna assume that name is like the name of the city. Yeah, and our country here. So actually, I'm gonna even call this here name of city. Oh, we got a. Oh, that was the. Actually, I'm just gonna make sure we're still connected. Okay, we are good connected. Oh, there's a comment. Oh. Oh, I'm curious about this comment. We're gonna read this quick here. Just doing some research in the background. Is this correct? Front end route. Yes. Yes, that is correct. So yeah, that like so what this is technically called is a kind signature, which basically just means like how many arguments can this type take? Um, how many arguments? Well, yeah. How many arguments can this type constructor take? So, for example, um, something like maybe, right? So, let me just do this here. right? The data constructor of maybe, where we have just a or nothing. This is implicitly, if we looked at the kind of maybe, right? If we were to actually open up like a GHC uh, REPL, and we know maybe, maybe we know maybe, we could actually ask the kind of the construct of maybe, and it would tell us maybe is a construct which takes another type to become a fully formed type, right? So it's basically allowing us to say maybe int, maybe maybe float, maybe bool, um, yeah. So exactly, that's all that really is. I really is my hot take on Haskell is that most of the most of the language extensions such as data kinds are basically ways of refactoring more complex code. Obviously, like we can be getting into very complex code where you kind of need to refactor, but ultimately, like we're not doing anything that breaks the base of the language, right? We're not now saying that here's a backdoor where we can use like an any type, like we can in TypeScript. Instead, we are doing something that we could, in theory, do with just plain old Haskell, but it would just take a lot more work. Um, yeah, and so, anyways, so going back to our front end DOM here, we have two input elements. Um, but we are not currently going to do anything with them, at least in the current code. And so we're going to need a way to choose when to do the request. Um, right, and where does this come from? Actually, I should say, if we look at like reflex, right, we have this function here that's called perform request async, and ignoring the arguments, or sorry, ignoring the type class constraints for now, we see that it takes one argument of an event of an XHR request and returns us an event of an XHR response, monadically. Um, so this is actually performing like a request from front end to back end for us. Um, I have another function. Where's this run API? Yes. This is also this is even more complex. I really want to figure out a way to fix this, but basically this is like the actual source code, which maybe hopefully in this case it's a little bit easier to follow. Um, I want to make this. I think like this is a problem I've noticed is that like when we look at this on Google, it just looks overwhelming. Um, in my actual code, I write it this way. This is just the format that I prefer because it's very clear to me like where I can start reading from, and then I can kind of work backwards into what are the type class constraints, right? Because like all of these type class constraints, like let's say there was no such thing as like a from JSON uh, type variable here, then there would be no point for this constraint, right? Everything in these constraints flows from like the actual definition here, and so that's where I start to read. So this is going to take a backend route, which I've named route. It's going to take headers, which is oh, I'm looking at the wrong one. We don't even need to get that complicated. My bad. We have a much simpler one, which is we're going to take a route, which is an obelisk route. Pardon me. Sorry, an obelisk route to our backend. Um, and an event which that event has an ability to be converted to JSON. Um, and then that is going to be put in this reader T config request error event T from JSON. What is this returning? This is basically returning um, essentially two events. Um, so this returns one event, right? The original function, which this just builds up perform request async, is why I'm showing it. This returns an event for an error and um, for a successful response. So let's say like we only ever listened, you know, oh, we only ever listened to like this event, and we only got errors, right? We would think that the nothing ever happened, um, and so like that's normally what we would get. We would normally get back an event no matter what, whereas this function kind of handles that for us by splitting it into two different events. So if we want to um, have logic that only pertains to what happens in the event of an error, it's very straightforward to do. And if we want to have logic that only pertains to what happens in the event of a successful response, then we do uh, whatever we want there. So I'm going to use this here and run API. Oh wait, sorry. I'm not used to my own framework yet. We don't need to use run API here. That's my bad. Um, we want to use what do we want to use here? Do I have any examples as set up? Um, we want to use request password reset. Do I have this here? Yes. No. FRP. I'll explain what this is in a second. Just gonna copy paste this because I always forget this code. So okay, so basically, we are gonna instead use requesting identity, and the reason for that is the run API explanation that I gave is for if we want to connect with HTTP, um, the HTTP API that we have set up. Um, pardon me, sorry, I think I gotta blow my nose quick. I'll be right back. Um, so yeah, instead we want to use this requesting identity function, and requesting identity is from Reflex itself, and I'll be honest, I don't know the internals of how this exactly works, but I know that like I believe Rhyolite has some definition for which this works, but basically we can use our request that we have set up. Um, yeah, I really need to look deeper into how exactly this works so I can explain it better. But basically, we can use our API here to make a request and get that back as an event. Um, yeah, right. So it's just like a very overloaded way of requesting something from a resource and getting a response back, and those both being, you know, handled as events. Um, and I use requesting identity to kind of simplify to just giving me the actual event back. Um, so let me do this here. So the API that we have is our weather. So we're going to have a public request. Was it public request? Forgive me, quick. Oh wait, this is from. I'm now remembering. Public request is the data constructor, right? Or is it API request public? That's what I'm thinking. Yes. Okay, this is what we want. So this is just basically this is from the Rhyolite framework now, and this is ultimately um, a generic wrapper um, around the specific data types that I've used to define my API. So we're not going to get deep into what that is, but what I do know is that I need to use this API request public constructor. Um, and API request public request weather, and that's gonna fail because I haven't given it the proper. Submit does not yet exist. Um, API request public is not in scope. Let's do that quick. This is rhyolite.api. And public request weather is also not in scope. Okay, yeah, fair enough. And submit is not in scope. So let's handle submit quick, and then I'll come back to my explanation. Submit is going to be from a button that we're going to make. So Reflex has a very simple function called button. We could build this ourselves, but it just comes right out of the box. And button should have some documentation here, but the first argument is that like what the text will say for the button. So this is going to be a button with the inner text of "click me" very excitedly, and that will give us back an event. Right. So this is like the easiest way for us to actually get back an event here is just through that there. Um, the quickest way to kind of mock up something and get an event is through just the button function. And now, what this is saying is that you haven't actually completed constructing public request of weather, right? So this is very smart about what types we have, um, as I'm sure we're starting to see. And location, it needs to have the argument of location somewhere. So I have this function here, this like kind of like stub that I basically, to be honest, I just copy and paste it wherever I go. Um, is I have this stub of um, taking some event elsewhere, which is currently submit, and actually this type is correct because I do currently just have a unit, um, and then building out my API request. What this for is basically fmap flipped. So fmap, right, just in case we are not familiar with it, is basically a higher order function that we can apply to a wrapped value and get back a new wrapped value, maybe of some other type. And so in this case, the f in this case is going to be our event t. And so now this allows us to operate on what is contained here. And so this is going to be impossible to do unless um, we have a way to get this information. So um, we ultimately we can kind of see, right? We want to pass location from this information. So how do we fill in the blanks here with our FRP? And the easiest way to do this is to say, what's the easiest way to do this? I think, man, it's been a while. Well, okay. Let me, if it was just the name of the city, then we would want to do something like this. We would want to say, let my submit equal tag of the current name city of you know with submit. What is I need to explain what tag is. Um, and so tag is kind of like it's one of the first like real FRP functions that you'll use, and I think FRP, by the way, is a massive part of the Jenga framework, or what I hope to promote use of, because FRP is I think the um, most important thing of it all. Um, yeah, it is a great way to build UIs, and I think that also stretches into video games, for example. But anyways, so behavior is basically a snapshot of an event that of a value that can change, but we've kind of captured a snapshot of it at a very particular moment in time. And then an event is what we've already talked about, right? So this can be a button click. So something that has happened, and then we get back an event here. So what are we doing? We are replacing this A, we're tossing that out, and we're taking that B and giving us back an event. So what does that look like is that the value of my submit is that whenever we click on this button, the value of my submit is going to be equal to um, whatever the value was of our input element at that point in time, right? And then that's going to stay static. So if I entered in Toronto, I click submit, the value of my submit is going to be Toronto until I click again. Yeah. So now what I'm going to do is I'm going to make this actually like the data that I need. And I'm going to work backwards one step. And I'm going to say my values is, well, how do I do this? So, I have location is location is the value that I want, and I'm gonna do this kind of like pattern that you start to see everywhere. And this is just basically using functor and applicative um, to apply this. So name why do I need to do this? The reason why is because this is a dynamic T text, right? This is going to be a dynamic T text, and so is this. So, right, and that's just because whatever value, right, whatever the value is. Actually, sorry, there's one thing I'm missing, which is we need to get the value. So I'm gonna fmap that well, let's make this a little bit easier. Named city L, country L, and then we're going to say that we want the value. So name city equals value from the name city L. Country L is the value of country, and the types of these, right? Name city and country are both going to be dynamic T text, which makes sense. That is just the type that we have from our DOM. And we ultimately want, we have these two as input. We ultimately want to get to a point of my value being a dynamic T location. If I can type it. And so like we're not trying to get rid of this context here, right? We could, like, let's say it's a maybe, whatever, and because a maybe is a similar structure in that it's also, you know, it also follows the pattern of the kind signature being the star to star. Um, and you know, we know that with maybe we could reduce it by saying from maybe and give like a default value, but in reflex we never want to destroy this, and I don't think there's even any way to do that, because what this means, right? Like this dynamic T text is forever distinct from if I said, um, forever distinct from if I said my string is of type text, right? My string, or my text, I suppose. Um, right? These are entirely different because I know that this is going to be bundled in with my code, and this is going to be a value that I determine at runtime. Um, and so I need it to be distinct in that way to keep myself honest, and keep my code correct. So the way that I'm gonna operate through that is that I'm going to use this pattern to build a dynamic T location where I take this location function, right, the data constructor function. I'm going to f map it over the first dynamic, which is going to mean that I have a dynamic. Um, I have a dynamic that looks like this, where I'm going to say it's a dynamic that's a function. Um, and then I'm going to apply it through the some people call it the TIE fighter function or the applicative function, and I'm going to use that so I can apply this function, which is partially applied, onto the last value of country, and so that's going to result then in a fully applied dynamic T location. Um, I'm going to need to import that. Oh, we have a question.
Yeah, so it was just me.
Yeah.
I was wondering. I kind of think I missed what you're saying. What was the value function doing again? Is that just?
Oh, yeah. That's a good question. So value is a class, or it's a class function where it basically says, like, does this thing have a value that we can get? And you'll see it's kind of like applied to a bunch of just different variants of basically input elements. Um,
Mhm.
and so the instance of input element is that we are using this input element. We just basically call the input element value field.
Right,
Um,
right. I've always just used that underscore input value thing.
yeah.
So yeah, that's just like a nice wrapper around all of that. So you don't. That's yeah, that's much nicer. Yeah,
Mm-hmm.
okay.
It's purely convenience, really. There's
Yeah,
there's no
yeah,
reason.
but it works for all of them.
Yeah,
Yeah, but as opposed to just having to know each specific one, you can just use value, and yeah, that's cool.
yeah, yeah, exactly. Um, oh, what the heck? Oh, okay. I have some silly decisions made. Text. Oh, condition. I don't. Oh, that's annoying. We'll deal with that. But yeah, no, that's all the value is doing. Oh my gosh, this is annoying. Okay, I'm gonna. Here's what I'm gonna do instead. I'm going to import from common types, just the location. I'm gonna. This is actually even just importing the. Oh, actually, I'm gonna need both the type level and the value level. So this imports the data constructors as well. And there's only one, which is location. Okay, so now going to 168. Let's finish this off. Um, my submit. Oh yeah, we still need to get this. So now instead of taking the current value of name city, we're going to take the current value of my value, and that's going to mean that my submit is of the type event t event t location. Right? We basically have just turned a dynamic into an event t, or a dynamic into an event. So now my submit is the um, is the event that we want to fire a backend request upon, and my submit contains the value of location. Right, the location is of the type location, and we now have a valid API request. This should work properly. Um, oh, fair enough. It's saying it doesn't. There's name shadowing, so you've already defined this name elsewhere. So I again, that's just a personal preference. I hate any name shadowing whatsoever. I like full disambiguation. Um, yes. Right. So now I know the country underscore applies to only here. Defined but not used. Right. So let's say um, yeah, we'll do nothing with that for now. Or actually, is it easy to display this? Can we just display res? No. Oh, because okay, we'll come back to that. Because we can't display it because it's an event, and we need a dynamic for display. Okay. So now this works, and now that we have that, I mean, we might as well. We run what are we running on? We're running on 8020. Um, I want to go to. This is also something I need to clean up. Trying to make a nicer way to kind of show off, like, and kind of navigate around the framework. What was it? We had was it weather? Click me. Perfect. So we have this awful looking UI here. Um, let's try and throw in a bit of Clash. Do I have Clash? Yes, I should. Center simple. Pardon me. Um, okay, actually, let's do it a little bit simpler. Center simple. I'm just going to pull this on the whole DOM. Center simple is a function from Clash. So It's actually, well, clash.reflex, I should say. There we go. Oh, and okay, I can't see where they are. So, center simple. I am also going to wrap this in more styling. I'm going to say that this is a let me see, L class. I could do something like this. Well, I'm going to use div class. Um, I'm going to use clash as well here. And I'm going to say that the background BG color is green for now. Do we have green? We need to import Clash. So we have Clash and we have Clash Reflex. Div class. Oh, yeah, and that's because I need that to make it clear what the evaluation order is. So this div class is going to wrap our input element. Oh, that's annoying. That's something I need to figure out. I'm going to just import Clash from here. Actually, that's going to get very annoying quick. I'm going to turn off name shadowing for now. I believe it is, what, GHC options, F no warn, name shadowing. Where do I have this? Options GHC. There we go. So I have a lot of like really crappy names in here. So, and that's because I'm trying to do things really quickly. So I'm gonna avoid name shadowing for today. Okay. So we have background color. What if we had? Okay. Border color. Um, what if we did this here? Okay, well, I mean, that makes it a little bit better, I suppose. Can we reverse that easily? Okay, you know what? Okay, so we have this really ugly UI here that we quickly built. And now we can see where our uh, functions are. So we're gonna also just give this a name. I think, does label exist as a function? Input element city. No. Okay, I'll just call this text for now. And here. Actually, I don't even know why I did that. Text country. Yeah, we have a question. Oh, never mind. I am mixing up sounds. Okay, so we have text country, we have city. So now, anytime I fire this, um, actually, here's what I'll do. I'll get a count just to show that we're doing something here, just to prove that like something is actually happening. Let's say count um, res count equals count of res. Does that work? Could not deduce monad hold. Okay, we need monad hold here. That's all that means. Oh, and that's because I'm not using it. If I say display res count, am I using count correctly? It's from reflex. Oh, because count is monadic, so I need to bind from it. Redundant constraints. Interesting. Okay. Defaulting to integer. Yep. This is complaining that I have a type default. I can actually, you know what? I'm gonna. This is a great example of something I wanted to show. Anyways, I'm gonna say that this is a type int, or oh, can I not? Is it not easy to do that? Maybe it's not. Okay, that that's annoying. I'll just do it this way, do the old-fashioned way. This is going to be a dynamic t int. Cool. And now this is going to display every single time that we have done something here. So if I say click, right, we that is saying that the request has actually fired. I don't know if I can see that on my back end. Um, let's go and further prove that. Go Jenga 2. What the heck just happened there? I'm going to say print here. Oh, I'll use put string line because print uses show, and I actually wouldn't want that for a. I wouldn't want that for a string anyways, because it would just make it uglier. So good to know that. Okay, and now did we get a here? Here, yeah, we see here. So we actually got a response on our back end, but we got a failure that it was um, incorrect. So let's go and quickly do this. What is the type of this? This is a event of either a backend error or our weather response. Um, and so here we are going to use. I'm going to keep this simple. Res. Let res equal fan either of res. And so this is going to be basically splitting how we see that we can actually use fan either anytime that we have an event wrapping an either, and we can say make both of those branches of either into their own event. And so now we have an event for if the request was good or bad. Um, and let me see. Can I now? Uh, Let me see if I can actually get something more interesting here. Um, cool. Okay, yeah. So I can. So I am basically saying, um, create this dynamic. Like hold dyn is a way to create a dynamic, and so a value that is changing over time. Um, we of course to create something like that intuitively we need like a starting value, then a way to change that value. So I have said that at first this is going to say nothing, right? There's going to be nothing here, and then we are going to um, show whatever we get back. Um, and so this is complaining because I don't have a type. There's no instance for show for my weather error. Weather error. Right, it's from, yes. Let's also do, yeah. Okay, so now this is complaining because I haven't. But this is good. I'm gonna ignore that error warning for now, because I know that we're not doing anything with this. But basically, this is gonna now allow us um, to show our errors. Right, so we got a bad API request here. Great. Um, and now instead we're actually going to go and do something like this. Do something with this. So we have finally set ourselves up to use our request. Um, sure. Okay. Let's just try this out for now, especially since it is AI generated. Where did I go here? And this is now complaining because we need network HTTP client. That's where everything is really coming from. I'm going to say network. I just know a lot of the modules by heart at this point. But there, you could find this, right? If we wanted to find like where this new manager comes from, we could of course just search it in Google. We need TLS manager settings. I also just happen to note that this comes from network.http.tls. Either decode I know comes from data.ason. And there we go. Let's continue to test this. We're going to click. And what did this print out? Failed to parse JSON. Key location not found. Okay, so that's fair enough because we're not really doing anything yet. I'm going to take a stab and say that it's probably our API key. Okay. Let's try this again. Cool. We actually got a response back. So now we are still not doing anything, but we can easily take this AI generated code and convert it to something useful. So, and I kind of purposely did it, right? I wanted it to only focus on things that it could do well. I didn't want it to think about my business logic. I didn't want it to think about how to pass in location and get back out a weather response. I didn't want that because I honestly don't have confidence that it won't screw that up. So I'm going to pass this the location to start, and then I'm going to get back a weather response. So I get back a weather response, and now I'm going to take a location. Location, get a weather response. So I'm not going to need this city anymore. And the URL, okay, so I can start unpacking this. Location, um, location I believe had a name field that I didn't like, but okay. Location, name, and country. Okay, I guess we have our API key. We have a city. We don't currently use our country, so I'm going to put that as that. Um, oh, it just. Oh, I guess fair enough. That's actually my fault because I just this is AI generated code, and I'm using it as if it's not. So the name is the city. Okay, so now what does this do? Oh yeah, and this is now saying that the um, my type is incorrect because I'm returning a weather response, but that's not actually what happened. So I now here need to change this so that I fit this to being the proper type. And so right away, like this is like kind of where Haskell types really get great for our thinking, is because like I can look at this and I now say, Dedoy, obviously this is impossible. This is just like, or not impossible, but it's very naive to assume that we're going to get a response back from an API or a proper response, right? The weather response is a data type that only pertains to a successful response. It contains no information about failure because if we have it, it succeeded. It's right. It's one of two future possibilities. So I need an either to encode those possibilities and say we either had a text failure. I'm just going to use this text for now. I'm going to say pure left error. Um, or I'm going to get a weather response, which I'm going to get back out of this function by saying, um, well, I'll show a short form for this. Let's call this WR at, and that refers to the whole thing. So I can just say pure WR. And I get back either an error. Oh, my bad. Either I get back an error or I get back a weather response wrapped appropriately in either. And I always qualify text. You don't need to, obviously, but it just gets a little bit annoying otherwise. Here, I'm also using overloaded strings. So I'm going to add that as a language extension. Um, you know what? Actually, no. I'm going to do this instead. I'm going to add it to backend cabal. Overloaded strings really not in here? What? Yeah, it is. Oh, I guess that's for a different reason then. So I do have this. I do have. I should have overloaded strings. Um. Oh yeah. Okay. It's coming from this, and that would have defined somewhere that the type of name is in fact a text. So it would not be interpreting the string literal as I was expecting. If none of that was familiar with what um, if none of that was familiar, don't worry. Um, Basically, overloaded strings just allows me to be flexible in how I interpret this. Okay, so now this is saying you actually got back a string, not a text. And so I can just like kind of keep this simple by saying, give me back this pact. So pack takes a string and turns it into a text, which is just a different representation for strings. No, I didn't save it. What is this name of lock? What? Why is this now failing? Oh, is it because I imported name or? Oh, because I also have that. That was just a. That's a bad way to code that. That I had name shadowing because I use the name that is the exact constructor. Usually I have the constructors named in a different way, but that's ultimately what happened. So thankful for that error. And now we have more name shadowing. Okay, so we and a perform request. We discard the error, or we discard the result. So perform request, we have now gotten back our result from the API. Um, and we can pattern match on this. So we can say our result, and we're gonna say case result of case the result is of a left error. We're gonna say that the user had a bad API request, just like before. But in the case of it being a right response, we are going to say pure right R, and to say that we had a successful response. This is still complaining about location. I'm just going to call this, defined but not used on 68. And yeah, that's true. We're not using error yet. So that's something we need to look back into doing. So now we click this, and it's going to say bad API request. It's not going to tell us. It's not going to tell the user anything, but we can see that we failed to parse JSON. The key location was not found. Oh. Uh, well, okay. I think I know why this is. Um, we're not even printing out the response body, so it's not really clear to us like why the API request failed. Again, ChatGPT generated code, so let's print this body just to see what actually failed, because this is definitely just saying that you didn't give me a city, and this is a fail. Parameter Q is missing, right? Parameter Q is our location. So in theory, one thing we could do as well is we could say we could have somewhere that we check if our if n is empty, right? If they didn't give us a real value, then we can check that, and we could throw that on the front end, we could throw that on the back end, we could do both. I'm gonna say now Toronto, and the country actually doesn't even matter. So yeah, there we go. We got back a response. but we're not showing it on the front end. So let's quickly go do that. And we are going to say, what are we going to do here? We're gonna also say no good request as our first starting state. Right, we're just building a string that we're going to display. Actually, this is even just dyn text. So I don't need to use display here. Display is a little bit more than I need. And I'm going to instead show the good side. Good. Good is not in scope because I underscored it. And now it's complaining that, oh yeah, this is because this is, I need t.pack. Because hold dyn is expecting a text. And this converts that to, well, it converts it to a string, converts it to text, and gets it back something to display. And that should work. Okay, so now we see we have nothing. We have 0 clicks, and we have no good requests. So now I'm going to say the city is Toronto, and we get back our response. Yeah. Not where I wanted to be in terms of the what's left to do. Well, we can maybe do this quick. No, we couldn't do this quick. I I mean, is anyone? You know what? I'm gonna do this anyways. It is 11:04. Is anyone just feeling like exhausted, or?
I'm, it's been 2 hours.
Yeah, that's fair. That's fair. That's fair. That's fair. Okay. Well, then we'll pick up next time. What we're gonna do next time is I thought it'd be fun to. Sorry, this is gonna be. Where the heck is it? No. Do I have T open? No, I don't. Where's Jenga? Gotta be some. There we go. What I was gonna do is I thought it'd be fun to have a set this up as an event listener. Event listener through WebSockets, so that we get an update anytime the weather changes. So we'll do that next time. We're going to set how we're going to do that is we're just going to set up a basically a backend worker to go and continuously ask for the go and make a request to the API at an appropriate amount of time, and then whenever we perform that request and we get new information about the weather, we're going to put that into a WebSocket pipeline and display the updated information. But for now, I think that's good. We did cover a ton today, so yeah. Any questions?
No questions from me, but that was really good. Thanks. That was really good to see. It'll be good to see some more of that clash as well, because that'd be really useful to have a simpler way to do CSS stuff.
Yeah, honestly, I think Clash is like I feel like the value of Clash even is demonstrated in like Clash Reflex, because like why I say that is I just like it kind of started as just a fun little project or whatever, but I kind of realized that like as I had built out better types for my my CSS or Tailwind rather, I noticed a lot of patterns, and so like I just started using those patterns in terms of like Clash Reflex. So for example, I just used this center simple, which I just realized like I am using this function here a million times over. Pardon me. I'm using this function here a million times over. Why don't I just use this everywhere? And I'll just make it a little helper function, um, and yeah. So it's pretty awesome. Um,
Yeah,
e-
good.
even most of the like the I mean not that um our site is very ugly right now, I will admit. Apologies for the patience on that, because like I had just been I thought honestly the Jenga framework was a better use of like time investment than making the framework, or sorry, making the CSS of the platform better. But that will be coming very soon now that Jenga is done. Um, but yeah, like all of this is done through Clash. I think Home is maybe a bit of a better example. This is done through Clash. Um, and um, it gets, yeah. I mean, there's a lot of information. I won't show the code right now, just because it's a bit overwhelming. But I'm happy to share that code, or any examples of Clash code at any point. Because it's just pretty nice. Like even one thing actually that I think is kind of cool is like this is all like responsive, and like also reactive, in the sense that like it changes with respect to like events happening. It also changes with respect to the size, or so the change of the DOM. And so like for example here, I've used Clash to convert how it looks, based on the size of the screen that we have, or based on the size of the window. Um, and like that's kind of actually built into Clash, is that like, you know, for example, column here um, basically says take up all 12 out of 12 spaces on the first two small screen sizes, and then shrink down to only taking 3 out of 12 units of that grid. And so call is just like really a helper function to do that. So I use grid layout everywhere, because I mean everyone uses Flexbox, but like I think you can get more declarative, I think, with grid. Like Flex kind of does things for you, and I want to keep it entirely declarative is kind of the key idea. But yeah.
Yeah, you've been good. Yeah, cool to see some examples played out as well. Yeah.
Um, yeah, and also like even even if you're like not yet ready to use Clash, sorry, Clash, Jenga, like you don't want to restart your project or whatnot in Jenga. Um, I think it's still very useful as a Hoogle server, because like everything that we could ever use is in here. So for example, I need to get my packages uploaded to proper Hoogle itself. But in the interim, for example, we have Lamarckian, is a package that I developed for the landing pages, and you can go and check out the library here, um, you know, through that locally run Hoogle. Um, so the documentation is lackluster at the moment, but that will be changing very soon. Um, same with Clash, right? You can get Clash through here and look at how to use it. There's a lot, like I really would love feedback, if anyone does use it, um, on what you think of the documentation. If there's any point at which you're like, I don't understand what this is, like that's a problem to me. That's a sense that's a sign of there's a bug in my documentation, and I need to explain that better. Um, and so like here, for example, this is kind of why I thought of this and why I'm talking about this now is like there's examples that are peppered throughout the documentation on just like how to use stuff. Um, So for example, here I'm setting the padding to being 20 pixels, and I'm setting the background color to being the Tailwind Gray 300. Um, Text size I'm setting to extra large and extra large on mobile, extra large 2 on small screens and above. So it's really cool. It's like I mean Tailwind is pretty awesome, I think, especially for just like quickly throwing stuff together. And I think Clash is like a great addition on top of that. Um, but yeah, there's some decisions I've even made that are like very specific to Clash. For example, like I kind of tried to make everything. I tried to make it so there's only one way to do something. Um, you know, which like within reason. I, because the reason for that is, at least for myself, when I use it, it allows me to more quickly identify patterns that exist in the structure, and then I can sort of take advantage of that sort of thing. Another thing that like I think I'd be remiss of talking about at this point is the templates package. So templates is just basically like there's kind of like a hierarchy of, there's the Clash package, there's Clash Reflex, and Clash Reflex, right, is like a very good package for building elements, and then templates is kind of it is basically just like a pre-built set of elements. So for example, if we want like a modal that has like, this is probably one of the worst examples in terms of the code quality. I put this here as a stub because I need to make this better. It's preset with a bunch of like R stylings. For example, a lot of this is generally useful, but like background color, this should be something that we can swap out. Um, same with I have two of them. Oh, okay. Yeah, this is really old code. But it works as a modal. If we want something to pop up, for example, if we go to Ace and we say video tutorial here, this is like the modal function, and this is actually the image source that you would use is for that button. But that kind of sucks. That needs to change. That will change very soon. But yeah, just a number of like sort of helper functions. Um, this is probably the most useful one. Is like this buttons module. And so I want to I even one thing I want to do with um this is kind of just an aside or whatever. Like I think it'd be really cool. I don't know how to do this yet, but if I could have in the documentation like an image, I think that'd be really cool. Like where I could show an example of like this is what the icon button looks like. Then I really think that it'd be easy to build out this documentation in like a very helpful way. Um, yeah. Um, what's even interesting here? I don't know. There's not really much.
You can embed images into Haddock.
Yeah. Okay.
Yeah, if you look at like chart SVG, for example.
Oh, nice.
Yeah. And the examples.
Chart type examples. Oh,
Yeah,
nice.
right in the middle. I think it's just random HTML.
Oh, perfect. Okay. Interesting. Oh, interesting. The Haddock has so many features that are just I'm only like just scratching the surface of it, feels like. So.
Yeah, you can make it so that the examples that you provide are actually the tests. So if you ever change your code, then the example would fail because the test would fail, and then you'd have to change the example to make the test pass. So your examples can be the tests for your actual code, if that makes sense, for your library, which is what I've used in some of my things. It makes it a bit messier because it kind of all, if you go look at the code, but in terms of like, you never have to worry that your examples are ever out of date to what you've just done with your code.
Hmm.
It's quite nice.
Interesting. Yeah, no, that's cool too. Kind of like is that that's not like through Liquid Haskell, or is that like through something else, or um
If you let me just bring it up, make sure I don't say anything.
It's called doc testing. So if you look up just doc test,
Yeah.
pop up.
Um,
okay.
yeah, it's test doc test. Yeah. If you go look at my edu library, I've used it all there basically.
Hmm. It's Cookie Box, right? Cookie Box.
Cookie box, yeah.
Love that.
Literally because it was the configs for my computer, my box. That's a cookie.
Oh.
And then cook with a capital, yeah. I
Edu.
Go into kind of any of the code base. If you go to source, test just has like one thing in there, but that's just kind of runs it, if that makes sense. But if you just go into any of these things, probably one of these, just any of these, you'll see like I have like a setup bit and then the examples before each of those things. But those examples, and when you run when you run test in the thing, it will run all of those examples as a test.
Hmm. Interesting. This reminds me too. Like, it'd be cool. Like Nick, you got some interesting libraries that I think like especially for beginners would be like awesome to use. This being like one example of them, because I feel like even what I love about this library is just like it's kind of like um. I, again, like you could in theory never use a library in your life, but I feel like it's almost like explanatory of like what can you do with either, like because I feel like when you look at either or the way I learned either, you just kind of you don't see it in context immediately. Um, I think this is a nice example. What's cool about the Jenga framework as well is that like so let's say we wanted to um, let's say you wanted to like contribute to Jenga framework or whatever, you could add a thunk. Um, I mean, yeah, maybe there's a better way to do things. Like maybe there's a there's probably a better way to do this, but there is a better way to do this. I know that. Um, you could in theory just go to the thunks directory and say git clone um, edu and then packet. And then anyone who's like using this framework could load up like edu through Hoogle. Um, so just a thought process. Um,
Yeah, if you download edu, you see as a flake, and in the flake I've set it up so that you can just run it locally as well, so you can run it Google locally and get it up there as a
true.
thing. So that's also possible.
Oh
Yeah,
yeah,
Nix
yeah.
run and then that Google there. You see the develop if you're so you can just write if you download it and then do Nix run and then that command there, it should just load it all up in Google with it for you, so you can use it locally.
Is that through
If
the
you do.
flake.nix file or?
Yeah, I think so. It's been a while since I actually looked at this. I don't think I did anything. No, it isn't a Nix folder, so yeah, it's all just through the flake.nix.
Okay, fair
It
enough.
wasn't this one I did anything more complex. So, yeah.
Hmm. Flakes are still something I need to look into. I just have such a what's the word I'm looking for? Critical mindset of them or whatever. Again, I've never used them, so this is all just from other people's opinion. So, but I'm seeing them
Uh,
used just everywhere. It's kind of like a thing that you just have to know, you know.
I think they offer some amount of convenience. Like I've noticed when I've looked at other projects that just use default.nix, there seems to be a lot more you have to do. But also, and I think that's because of the fact that you get a flake.lock file. So
Mm-hmm.
effectively, all that thing of pinning everything yourself is really handled by the flake.lock file. And then
Mm.
yeah,
Like
you just
for like for garbage collection, it wouldn't delete anything that you have in that flake.lock file. I guess.
yeah, exactly. Yeah, so if you do garbage collection, you do your garbage collection, fine. So if you're not using the project for ages, let's say you've not done any work on it for ages, if you run garbage collection on your system, it will just get rid of everything.
Mm.
But then when you went back to that project, you'll go look at your lock file, and it'll just basically install exactly what you had before, so nothing would have changed, unless you say, I think it's Nix update. I can't remember getting that wrong, but there's a way of just making your it might be upgrade in fact. But yeah, there's a way of it just saying, hey, reload the, delete basically delete the lock file, rebuild the whole project, and it will build it with the latest packages instead.
Hmm.
Obviously, you might have to do a bit of debugging there if something's changed. But yeah, it makes it a bit simpler. I think from a personal thing, I can understand if you were running a big project and you wanted to make sure everything was very much there. Um, I think one of the things I probably would change from what I'm doing here is you see I call Cabal to Nix from within the flake. I think what I might start doing is using Cabal to Nix to generate a Cabal to Nix, fixed file so that you get all the packages named there and then pull that through. So just do it as a kind of like an extra step and then pull those things through into the actual thing because at the moment it's a little bit hidden of exactly what you're using because it's all happening inside of core Cabal to Nix. It's just taking a file and doing that. So it'd be I think quite nice to have a little, at least somewhere you can go read exactly what version of everything is being used. If you know what I mean.
Hmm.
Um,
Yeah, fair enough.
so yeah, yeah,
I actually, it's kind of funny because I was gonna go the opposite way. Like I've used like the Cabal Nix command line tool to build a default .nix, and then um I'll do exactly what you're saying. I kind of like I just found that it's like very straightforward. Um, like I feel like I don't know. It doesn't seem super interesting to me, at least at the moment. I think it's definitely more documenting to do it the way that you're talking about. But I don't think it's like necessarily super bad to do it the this way because like
yeah.
it's
I think it's. I think what you kind of got me though was the recent one of the recent issues something's happened was it was with but it was with npm or something and suddenly a version of something was really bad and people needed to update and it's like well I'm not using npm here but if I was using a project and suddenly somebody says oh this thing in this library is really bad you don't want to be using it there's a real issue with it at the moment, if you look at all my projects, I'm a bit like, it would take me take me a lot of digging to figure out exactly if I'm using that exact package because
mm,
it's kind of all happening without me seeing. So I would just like a report of somewhere where I can look really. What are all the package versions that I'm using of everything, just so I can just grep it.
right.
What am I using? If I am I using this product? Oh, I am. What version? Oh, this. Okay. I need to change that, and then you can think about how to change that, as opposed to having to spend a lot of time just unpicking exactly what packages you're using. I'm sure
Right.
there's other ways of doing it, but
Yeah.
I'm a grep kind of guy. So if there's just put it in a file somewhere, I can grep it. It's
Right.
fine.
Right. No, that's good to be a grep kind of guy. I feel like that grep is like absolutely essential to being a senior developer. Like if you're going through a lot of code and you don't know how to use grep, um, or you're not comfortable using grep, it definitely makes things take longer. I think. Um, yeah, what I'll say too with that, like, I mean, yeah, I think at that point, like, yeah, if you're getting more customizable with what you're doing, then of course, yeah, I think that makes sense. And you would just like override the packages that you have. Um, if there was like a Haskell package that you didn't want to use, right? Override that, or do a Nix packages override. But yeah, you probably know how to do that already. Um, yeah.
I can't say I can just write it off the top of my head,
No,
but I
that's
can.
fair.
Yeah, I
That's
can.
fair.
I can. I have to go searching. I've got a few places where I've got overrides in other projects, so I'll just generally grab and adapt, basically.
Mm-hmm. Yeah, I wouldn't know how to do it with the flake. I mean, I'm not sure if there's a flake difference or whatever. This is like this even this line here. I'm like, this is new to me. But I guess question like you can if I make a derivation, can I easily use it in the context of a flake? Like there shouldn't be, I mean, like there shouldn't be any reason I can't use like a separate .nix file in the context of a flake, and there's
Oh
something
no,
else I need to think about, or
no, you should just be able to import it largely and use it within the flake. If you do make your derivation, so like if you see all my libraries, I make them as flakes because actually then when you want to import, so I'll trying to think if I can think of something I've got that's up on my. If you go to, it's not anything that people might understand, but if you go to one of my other projects, I think it's just called KVM Switch. 'Cause I'm building something with my brother. If you go to KVM Switch, this you can see has actually got a Nix folder, so I've got lots of other things inside the Nix folder as well. But that's largely stuff for just for fixing cross compilation. So you like copy to PyNix. So these are just things that you can then import like modules. But if you go to the actual Nix file, the one above, sorry, this is just a
all
bit
good.
of other stuff. No, so the one in the actual flake.nix and the in the yeah, here we go. What you'll see here is if you scroll, you can see it just there. It says edu.url github cookie box /edu. So I've imported that library into this project, and that's all I have to do because it's a flake, and I've just put it in my inputs of my flake. I don't have to do anything else about pinning stuff and blah blah blah. I just import it here, and my Cabal file can just use it like any other thing. I don't have to do anything else. That's basically it with the edu.
Oh, interesting. Um,
I don't. Yeah. Do I reference edu any further? Yeah. If you go down, you can see it overrides actually with edu. Here we go. Sorry. So there's a bit more stuff you have to do. Um, but yeah, effectively that just makes it completely available
yeah.
in your project.
So this is like implicitly probably calling like fetch from GitHub or whatever. Like this is doing right
Yeah,
or
that's
okay.
fetching from GitHub. Yeah, that's what the inputs. So inputs does when you put say inputs something .url, you're effectively saying go grab this thing, call it edu. That
Mm-hmm.
is from this URL. Yeah, so effectively, yeah, it's just implicitly doing all that.
That's kind of nice. Okay, that's decently nice. Um, and okay. That's I'm starting to see the appeal.
And so you see this also. I have all the stuff here for about. So this is this is going on a Raspberry Pi, and obviously compiling Haskell on a Raspberry Pi isn't a nice thing to do.
Yeah.
So I effectively this lets me target Raspberry Pis as the Raspberry Pi kind of architecture, and just compile to it.
This is sick. I was like
Yeah, a lot of
KVM, like
trial and error, a lot of yeah, a lot of things. So KVM switch and making a KVM switch, which will hopefully allow me to. My brother's doing all the actual board design stuff, but we're hopefully going to make it so that you can actually have like a HDMI changer switcher would be um, display port really, but effectively allow you to just say send this monitor to this machine, send this monitor to this machine. You can have multiple monitors and independently send them to different machines. If that makes sense. Instead of with most KVM switches, you have to switch everything all over at once. It kind of lets you send all the different peripherals to all different machines. That's going to be the idea anyway.
interesting. That's
But yeah,
cool, man. Holy crap. This is I might dig through
lots of
this.
trial and error. Yeah, I might not be able to answer all the questions on it. There's a lot of just, Google, even a bit of AI, and just copy and paste and then hack on it until it works, to be honest.
Yeah.
But then, yeah, so this is so this is some, what was this for? This FFI. This is GPIO stuff. Yeah. So this was using one of the libraries, because a lot of the libraries for um, Raspberry Pi seem to be a bit out of date for Haskell. So this was really simple for that.
Hmm.
Some of the other stuff wasn't so simple. So the FFI stuff for the GPI thing was fine. It was really I think it's the LED spy.hs. That's a bit of a hack, to be honest. But
I, I
anyway.
I'm curious. Like I remember hearing a while ago that doing embedded systems on Haskell is considered a noble pursuit, in the sense that like it's very challenging or whatever. Did you have any issues with like the size of the executable or?
Um, so far, not an issue with the executable. Getting it across onto the Raspberry Pi was probably the thing I've had the biggest issue with.
Hmm.
Which is why if you go to the Nix thing, you'll see there is the Nix folder. You'll see that I have a copy to pi.nix. So install and then install Dutch, it is a thing. So basically, uh, these are just all the steps I constantly had to do to get the thing onto the Raspberry Pi. But no, if you compile it to a binary and then import it as the binary onto the Raspberry Pi, I've not so far had any real issues with that.
Yeah.
Whether or not this project gets too big for that, I don't know. And then I might have to go write everything in Python again, which would be a bit annoying.
Right.
But um, so far that's fine. The issue is compiling on the Raspberry Pi with thing. You can install GHC on there. You can get everything, but once you're just the amount of times you'd be lucky if it finishes compilation. It just
Yeah.
generally hangs at some point and just dies. But I literally am compiling all the code on my main desktop machine and then just copying well, not just the binary. I have got Nix on Nix on the Raspberry Pi as well. So it is a Nix derivation that I'm copying across, really, not just
Mm.
the binary. If that makes sense. Um,
This must of course gets into like cross compilation,
mm.
right? Or I like is that how
Oh
you're?
yeah,
This
yeah,
is cool. I I'm just seeing that there. This is so cool. I think this is a great example for anyone who's not familiar with Nix. Like for actually two reasons. Um, One, like I mean, we can kind of see we basically like I feel like a lot of Nix is just basically building a fancy Bash script. You
yeah.
know, like it basically is. But the reason we use like Nix over just a Bash script, um, I mean, I guess Bash is kind of like it's not the best language in the world. But like the way that we actually use it is kind of like to
Bash is the best language. I'll fight you.
okay, yeah. Zenon, I was waiting. I was waiting for you to come in here. I was like, oh my god, Zenon, like very very minimalist. I was thinking about you in this explanation. I'm like, there's a reason for Nix. Bash is great. Bash is no, you're right. Bash is the greatest language because you can do just about anything with it. Um, but I guess we use the way that Nix is used is to build Bash scripts that kind of like um, deal with different environmental factors, like for example the host or like cross compilation is a great use of Nix. Um, so I mean, although you can't compile to Windows, so that's kind of a a hole in
Well,
the
that's
argument for now.
yeah. Well, yeah, there is that. But I mean, the thing is if you're staying outside of the Windows world, the whole problem with cross compilation is making sure you're using the right packages on your system that you're compiling,
Right.
but also using the right packages to the thing that you are compiling to, and that you're wrapping. You know what I mean? So like the
Yeah.
problem is the whole problem with doing it without Nix is that I want to compile using this library, but I actually want to compile the code to use this other library. So you kind of have this two worlds of like, do you know what I mean? Like
Yeah.
I want to use it all in this one world, for my own system, but I want it to target all these other things, which is quite difficult to do. Whilst Nix makes it fairly trivial, there are, it has been quite a lot of trial and error to get to where
Yes.
this code got to, and I do feel like at some point, I think again like that whole kind of like I think there's also like I think you can really I think there isn't the community, and I'm certainly not the person to do this. The community, someone with Nix really needs to spend some time really putting some good education content out there,
Yes.
beyond just the kind of basic stuff that you find on YouTube, which is fine up to a point, but it kind of doesn't teach you how to really solve these problems.
Right.
Um,
It's so hard
but
to.
also, I think that
Sorry. Go ahead. Go ahead.
but also they just need to also, I think, whilst doing that, you need to get a couple people in the room really, which is someone who's very Nix and someone who's very Flake, if you know what I mean, and provide a dual like this is kind of like because there is a lot of overlap, but then there are things that you really would only want to use Flakes for, and there are things that you probably wouldn't necessarily want to use Flakes for. And I feel like I've come from a very Flake. I just happened to come across the Flake stuff and went down that route. You've obviously come from a place where they don't really use Flakes,
Mm-hmm.
and so it then comes like we're kind of half speaking the same language when we talk about this stuff,
Right.
and we're kind of half not. And it's I think that those two worlds haven't really been unified, I think, very well.
Mm-hmm. So what you're saying is we should jointly release a tutorial on Nix.
Maybe, yeah.
Yeah. Yeah.
Well, I think we should, that'd be a good project. And
Yeah.
if we can get to that, I think, be figuring out what I think would also be quite useful, maybe to try and pick another language and say like, because at the moment I'm very good at using it for Haskell
Yes.
projects, but I think you also need to be able to generalize it to the point of like then you can teach people like, well, yeah, but you could use this for a Python project or
Right.
a Scala project or any other project. What is the general thing? What is the general things that you can do to really get people to use it in all instances? Because Nix is obviously bigger than just Haskell.
Yes. Like even I'm thinking like, can I do this quick or? Oh, okay. Just like I want to show a quick example. Make me a package JSON. Like for JavaScript, I kind of think that JavaScript is like the most chaotic of all Nix use cases. Um, because I mean, like look at node modules. What's it called again? Package.json. Sure. And like it's wildly different. Like I thought like I was expecting just like one default.nix to happen, right? Like even just again for comparison's sake. Cabal init. I knew it was gonna happen. Okay. Cabal to Nix. I don't know. Let's just do it as a shell, right? I thought this was like a generic like utility for all of Nix or whatever, and it was just like Cabal to Nix is like a um a synonym
A
or whatever.
wrapper, yeah.
Yes.
Yeah, so there'll be like a two Nicks kind of thing that produced, and you'd have the different ones.
Yeah.
Yeah,
But yeah, it's a very clearly like a different. There's some languages that don't even have it. Like um, I, Rust doesn't really have it. Although like Rust, I will say is like, or I guess I have crates to Nix or something like that. Or it's like, but it's not even like I've even found like Rust I don't know. This kind of makes sense when I say it out loud, but like every single language seems to have its own way of doing nicks, I guess.
Yeah, which makes it quite difficult to then produce. I think it's probably why no one's really produced a particularly great intro to Nix, because it straight away depends on then what language you're going to go off and use it for.
Yes. Like this is everything that we need to, like enter in a shell with our Haskell project. I mean, there's maybe some small things we could change or whatever, but then like
Mm,
if we go back into this here, like we cat default.nix. I mean, this is simple, but then cat
yeah.
we need the node env. Like I don't even know if we're supposed to. I guess
Yeah,
like
oh, crikey, that's massive.
yeah, absolutely massive.
But I think isn't that just also that I think that is also just the sign though of like how much like Haskell is so much more declarative, including inside of its build system, as opposed to something like Node, which is not particularly. Do you know what I mean? So there's
Right.
probably a lot more having to be done to make Node behave more declaratively, whereas with Haskell building, it's a much simpler job to make that behave more declaratively. If you know what I mean?
Yes, absolutely. And it like, and I think even just like Node, like you have way more packages that are
True.
you're depending on. I mean, which isn't necessarily a problem for like the design of it or whatever. But yeah, like I think it's more of what you're saying of like, is it in nature a declarative thing or not? And so like yeah, I don't know. That I think that is like really the main challenge of teaching Nix is just like, yeah, Nix for what? Because
Yeah.
even like I mean the Nix pills, right? Like they don't really get. Is this not? Oh, okay. What? Have I?
No, someone's literally 2 years ago need a more modern Nix pills.
Yeah,
That's, yeah.
I apparently have. Do they have pills
But I
anymore?
found this before, and obviously, I know a little
Yeah.
bit of Nix before, but I've been like, I want to go make my Nix a bit better. So you start looking at something, and then you'll just find again it goes down a very either it just stays super high level, and you're like, well, that's nice to have that big picture stuff,
Right.
or it goes in a very specific example, and you're like, well, I don't really ever need to do that because I'm not doing that. But I don't know if that's just is there a better way of approaching it? I'm not sure.
Right. And
Apart from
even
just lots and lots and lots of examples.
I feel like this is as granular as they get is the call package function. And you're like that's like it's actually this is not horrible because it's like, most of Haskell um most of like the this is kind of used everywhere, right? If we like just search for a call package um under like I know under Haskell packages that like it there's a Haskell call package that's like everywhere. Is it top level Haskell packages. Um, I forget how to navigate this all, but like basically like they do use call package everywhere. That is definitely
Yeah.
true, but oh, did I lose my? Yeah, implementing call package. They do use this everywhere, but it's still like not. I don't know. It's not. It's there's way more to talk about, I guess.
I think yeah, I do. I get the feeling this was written by people who probably wrote Nix, as opposed to written by people who learned how to use Nix for what I mean.
Yeah.
Because you have a different people who've written something. Obviously they know more about it than anyone else, but it's generally not give, it doesn't necessarily give you, it's normally so far more granular in some kind of random place that you ever need to really understand, and it
Right.
doesn't necessarily give you, there's a balance between a big picture and the granular, and it's kind of somewhere right between those 2 points. But generally, when you, and I do the same thing when I've written something myself, any code myself, if someone asks me about it, I either go very high level explaining it, or I'll
Right.
go into really specific detail about something that's kind of nice in your head. So
Right.
it's difficult,
Yeah,
really
it's.
difficult.
I feel like even with like trying to when you end up explaining in that way, it's like you know in the back of your mind, it's like it's because I'm missing like a simpler way to sum this up.
Yeah,
I feel like even this is was it this that I was looking at? No. And then I'll find a link. Oh, this is it. This is it. Like I think this is like this even feels like where you should start with Nyx. You know what I mean? Like where it's funny. It's even like this is kind of another funny case is that like we talk about cross compilation. And actually, we can technically, where is it? MinGW, you can compile to Windows. Um, I guess you can't run Nyx on Windows, but you can compile to Windows.
yeah.
Um, so it is technically cross-platform, um, but and same with any of these other cases, right? Like Android, the reason we can compile to Android is because of basically you know um, Nix packages handles the cross compilation, and like what's cool about or maybe like the like what I'm trying to say is I think this is like maybe the way to explain Nix properly is that like it feels like it's all about cross compilation, like all about cross compilation regardless of what package set you have, if that makes sense. Like,
Yeah, I think because even if you, it's not really cross compilation, but even if you're like, it's like the first thing that made me really interested in was kind of like, um was the idea of like, oh well, when if you're on your system, you're using a particular library, um and then you download a project, but that project needs you to have another version of that library. Life starts to get quite painful, especially if you're
yes,
jumping between different projects, or if you use that library somewhere else for some other reason. It starts to get really, really irritating, and that's obviously when people start using things like Docker. But it just feels like you end up with these things, and it's kind of a constant problem with most projects. So you end up then having this stack after stack after stack of stack of different things just to run, just to work on this
right,
bit of code. And I feel like Nix is very good at the fact that you effectively get, because you get the packages, because the way that they name the packages, just with the package manager, you basically get everything from my perspective
right,
that I need from Docker. Other people will use it for other things, obviously.
right.
And so it kind of it started, for that reason. But yeah, it's some of the language is still a bit, I think, awkward, and like I
Mm-hmm.
said, it's just, I think, starting with cross compilation is a good way of doing it though, because it kind of gets people to,
Well,
it
because
gets people to think about we're starting with the packages. We're starting with the packages. You know what I mean? But
yeah,
yeah,
and even what like the reason why I'm like thinking about this is I remember, when I started using Nix, like I really did not know what I was talking about, um, and even now I feel like there's still so much for me to learn with Nix, like so much to learn. But I feel like that's
yeah,
even at the point of like, well, I need to learn more about Linux. Like, there's things I don't know about Linux and how it works. That's I think where my like gap really is. But even like, why I think this is an interesting way of explaining it is because like, I thought like, oh, like a Haskell package, the way that Haskell package is handled different, that Haskell package needs to be handled differently based on the platform, and this can be true. But even like Nix kind of makes the distinction of like, we have actually I think I have it here. Um, shell.nix. Executable Haskell depends, right? We could have, for example, executable system depends, right? And we could say, like that. Oh, it depends on um, some C library. Maybe it depends on like FMMPEG for audio and video analysis, right? And we could do that there. I believe it's just like this or whatever. But like so, that like that handles like the system piece. So okay, then going back to like the rest of the library, like that Haskell code is kind of like that's a very different thing than like you know building Haskell code is very different from building the Haskell compiler, right? Um, like if the Haskell compiler is built on some platform, then you can build any Haskell code. So like really, like I think this piece becomes like a lot more like interesting, in that it's like talking about like, when compiling code, we can distinguish between the build platform where the executable is built and the host platform where the compiled executable runs. Um, and that like GHC is going to take our source code and perform the cross compilation, right? Like we don't need Nix to do the cross compilation. We can use GHC just in raw form to compile to Android or whatnot. Um, so it's GHC that's handling like the platform, um, you know, how to behave with respect to the platform, and then everything that is like that sits on top of GHC that like requires GHC to be built, right? Like the Nix derivation of like edu that like requires GHC to be built, to be actually like a usable thing, right? Um, so where am I going with this? So I guess like knowing that like it's kind of made me think, oh, like basically like although there's like so much that's going on in like Nix packages, like all of these are kind of just organized by like what the compiler is, or like how do we actually use this source code, and then run it in a bash script, right? How would you run Haskell code in a bash script? You would say, you know, um, you would say GHC, um, you know, uh, main.hs or whatever, and you would actually build it and then maybe run the output, or run the out executable. Um, so I don't know. I like. I guess
I think
the
I think
view.
you
Yeah. Sorry. Go ahead.
as I was gonna say, if you go from the point of explaining cross compilation, I think you'd have to decide. You'd have to really, I think, go into the idea of maybe you choose Haskell, maybe you choose a different language. I don't know, but you'd have to go into what is the whole stack of, when you're building a piece of software. Because I think it's very easy to think of like, oh, I run compile build, and that's what builds my thing. But when its fact is that it'll be pulling certain library. You know what I mean? You've got to really get understand like that building actually. And I've heard this before, and the thing is, I don't really know C myself, and this would be the big problem. But C is kind of sometimes the best way of explaining really that whole stack of stuff, because you don't get to you don't nothing does it for you. You have to do each of those steps yourself. Like you need to make file, you need to do, you know what I mean? You need to make sure.
Yeah.
And I don't know. Sometimes I think with the higher, maybe, and I think this is probably why they're using C as the example in this cross compilation example. But I think the kind of assumed knowledge there is that, and I think a lot of people don't, including people who are developing, really good developers, always understand really that fundamental stack of things that's happening underneath every time you run build this project for me. And I think sometimes you kind of expect Nix to mean that you don't need to understand that. Unfortunately, I think that's just unlikely to be ever true. It's because, as we've said, each programming language comes with its own stuff. So
Yes.
you need to understand what part of the stack is each different. Like if you're using Python and pip or something, what is it? What steps in the overall building of a project is pip doing for you?
Right.
Because if you understand that, then you can understand how you need to wrap that up with Nix in relation to other stuff. Does that make sense? And I
Yes.
think that's the hard thing, is that you've got to fundamentally have that kind of atomized version um, um,
Hmm.
of what a general build is. I don't know. I don't know if
Yeah.
that makes sense.
Totally. No, totally. And this reminded, so like there was recently an issue I was working through. I had to get super deep into how compilers work. Um, I've seen this issue in Nix packages all the time with template Haskell. I thought this was so cool. Um, Haskell does not work, and like I just see template Haskell as like kind of a culprit everywhere, and I'm like, why is that? Right? Why is that? Like, I see people hating on template, like that really are frustrated by template Haskell, and then there's me, and I'm using template Haskell for Clash, um, and it's there's a lot to it, and I'm like, well, why does it matter in the context of like Nix? That just feels strange to me or whatever. Um, and like I kind of thought it
Is it
through.
big?
Oh yeah, go ahead. Oh,
Can we guess? I'll have a guess before you explain, if you don't mind.
yeah.
Which is it because template Haskell isn't particularly declarative? Is it because, like, if you think about it, like everything in Haskell is very declarative, but template Haskell's the thing is going to generate it, but it's going to generate it at compile time, so you don't know what it's really going to do until you're actually compiling it. Is that right, or am I off base there?
I mean, I'm not sure. Like there could be cases like I remember you mentioned this like a while ago. Um, and it is a bit. I think it's like maybe a better way to describe it is like it's boxed. Like for example, anything that you anything that you compile from template Haskell, you have to return a QExp, right? My expression has to be of the type QExp, where Q is the monad,
Mhm.
and exp is like like the Haskell expression. So like yeah, this can be um oh oh the where did it go? Okay, there we are. This can be what the this can be like maybe for example 1 plus 1, or this could also be hello, and it's really the same thing. The reason why is because like I mean at least to my understanding is that like because this is this is kind of wrapped, and that like we and it's wrapped in a box we can't unwrap. Like there is this expression. If you actually print out the expression, it's like this massive thing, like this huge massive thing. Right? Do we have? It might be a little hard to see if I can do this. Set. Yeah, it'll print that out, and we'll see like that. These are both like of the type the same. These are both the same type, right? Um, but like they're the actual like underlying data type is different. So it is like it'd be kind of like the same thing as us saying we can return any type in our function if we did something like
Yeah,
this. You know, like data
this
my type equals stringy string.
this feels this feels like very much like what effectively you could say that like the Python type system is like 'cause Python has you can make an argument that Python has a type system of one type,
Yeah.
which is just types, and that all the types then come under that types. And this is kind of what I feel like template Haskell does is it kind of pushes us into a more um, and look, if it's done well, and I'm absolutely happy to use libraries that use template Haskell because if it's done well and tested well and it works, then fantastic.
Yeah.
But the problem, the thing of what I don't really like. The reason I like Haskell is for the very much that it's not like Python, and I have all the types. So I feel like when I look at doing template Haskell, I'm like, oh, it feels like I'm being pushed into writing
Well,
like Python again.
the one thing I'll like stop you on though is like let's say I did this. Just that's not gonna work. Really? Oh, that's gonna work.
so so that's what I mean. Like it's you've lost all the protections that which is then so you need to be really careful with template Haskell. So it's you do lose this kind of um yeah, that makes sense. The kind of not maybe declarative. I'm using the wrong word there. Maybe it's not the declarative side of it. It's the types. Yeah, the type safety you've lost, in my opinion.
Yeah, interesting. Um,
Which is,
so
to be honest, I am talking to someone who's literally looked at it and gone, this looks scary to me, so I've never really used it. So I am not an expert on template Haskell at all. I've just literally gone, this looks a bit scary to me, so I'm going to steer clear for now.
yeah, the one thing I will say is like I mean I am using like I don't there's kind of a lot of different things in template Haskell and like when I'm even oh I'm silly. I think I need to do this. Um, let's do. Oh, this is the type of int. Let's say. Or is this okay? Yeah, I don't know. I don't know what the heck is happening there. Okay, I guess that's one possible case. I've never run into this issue. The reason why is like most of the time I'm really just calling, um, like uh these really give you a lot of flexibility. That syntax. Um, most of the time I'm writing a function like from A to B, and then I'm calling that like in my function. Um, and so like this, if this had an error, this would fail. That's actually like part of why I use template Haskell in so many different places. So like for example, um, if we go into landing page, I found like a fun case. So this is our like our router for our static landing page. I'm using template Haskell here, and what I found is like other errors that like would normally could normally become a runtime error actually were promoted to being a type level error. For example, I tried to have a case where um, I had I have this like JS sort of like crappy little JS library that I've built, and I'd have like JS Func 1, I'd have JS Func let's call JSF, JSF 2, JSF 3, and I would have it just like this. It would be like returned as a list instead of being a tuple, because I just didn't want to write one for each individual tuple. I wanted to build it for a list. And if I ever like tried to say that it actually had 4 elements, it would fail. So like it was kind of like and the reason for that is because like it tried to evaluate it tried to do a runtime action at compile time, that runtime action failed, and so the compile at compile time it failed. So like I like there's cases where I guess there are cases where you can make mistakes with template Haskell. But I feel like even like that's kind of the case with like a lot of like advanced Haskell is, we have the ability to, like if we really want to, we can make mistakes. Like for example, like we have um, unsafe perform IO. It's just, right, this backdoor into the IO monad. Um, right, if we wanted to do a print statement when we do like addition or something, we could, and we would still have like a pure addition function, or it would look pure, but it would just have a backdoor into IO. Um, but yeah, like we just we can screw it up, but there's many ways to avoid um, like doing that, I guess, if that makes sense.
Yeah, no, I mean, like I said, I'll use a library if it has template Haskell. I'm not anti template Haskell in that sense. I've not so I've not really got to the point where I want to take off the because that's the thing is like the unsafe for IO maybe allows you to have some nice thing like I don't know, a print statement to make sure you do or some logging. Let's say, well, I need to log this here and I don't want to turn it into a log thing. But then you lose, if something goes wrong at that point, you lose the traceability of that error must have come from here because actually I wrapped everything up into an either statement and blah blah blah,
Yes.
right? So it's not to say that there's never a case for these things, but yeah, I still very much, the reason I like Haskell is because it forces me to write good code. So I
Yes.
try and stay away from things that allow me to write bad code. But that maybe as I get more experienced, I'll be like, you know what, there is a really good case here for template Haskell as opposed to, and like you said, if you can actually use it to elevate things into a compile error, which would have been a runtime error, that's a real advantage. That's a real advantage of it.
So like even an example here is where's compile style? Compile style. So I have this compile style, and this is something I use in the context of template Haskell. But I still have like, and actually this is starting to bode nicely into what I was originally talking about with the template Haskell issues, or the challenges. Is that like we have this full, like we have the full power of Haskell at our disposal when we use template Haskell, right? So I can anything I can do in Haskell, any logic I can write in Haskell, I can just perform that in the context of template Haskell. So where do I actually use compile style? Instance compile style. So I basically I essentially is this box padding? Oh, okay, box. I want to look for box. Where's box? Box. There we go. Compile style. So like in here, I am able to. This is why I use template Haskell. Is I want to be able to say that like where do I specifically do this? I check. Where do I call this? I call this. Yeah, this is basically checking if I have given um, two instructions for how to position something. So if I said like that I want the position to be centered, and then I want the position to be, actually I guess I technically need to do this small detail. If I said position centered and then position I don't know, left aligned, which is not a real thing, but I'm just making it up. Centered is a real thing, but not left aligned. This would throw an error saying you have given me invalid clash code.
Right.
So Yeah, and at compile time, I would see that. There is like the point you make about traceability. It's a little annoying. There's probably a better way to do this than I am, um, but it doesn't really tell me where it's complaining about, like as well as it would for a normal error. But that's just probably because I'm not using template Haskell to the best way that I could. Um, yeah.
Um, I think it might be. I think that might be just the issue with, and that's why. I think that just might be one of the issues with template Haskell, though, is just because it's slightly less. It's a bit more ambiguous in its nature. Because otherwise, we'd just use template Haskell to write everything, wouldn't we? And it wouldn't be template Haskell. That would just be Haskell. So
Well,
there must be a drawback from breaking out template Haskell into template Haskell, if that makes sense.
the main. I mean, I'm like the one that I know, like the one case I can definitely say for sure that there is a fallback or a drawback from template Haskell is like compile time. So go back here. Not gonna refresh. Is like in order to do this, like if okay, so like this works on the basis of compile steps, right? So if we had like module one, and in here we have like we have X is like compile time, um, make one or whatever. X makes something. X is some Haskell, some actual Haskell type. Then in module two, we are able to say um, Y equals um, make something with X, and then I'll give a 1 or whatever. Um, then, like, we need, like, the compiler needs to handle this process. Um, because like we're not using like the template Haskell code here. We're using like the generated Haskell code. So like let's say X is like an integer, right? And then Y is, I don't know, also an integer, just to keep things not interesting. Then we like the compiler needs to be able to handle this, and so basically that comes down to the linker step. So if you watch, I can actually perform this. If we watch, um, no, you know what? Here's actually a better way to go. I'll do this. I'll just do it for Ace. I'll say nix build android.nix. Just so we can kind of see it compile. Fair enough. I guess a bunch has changed. Okay, so we can kind of even here. Or let me get a better example. Yeah, I'll use this here. I lost it. Okay, well this is also an example. We're seeing like compile main, and at that step, I used to see this and not understand why it did this. Like it seemed like more work than it needed to be. Um, but I don't know compilers perfectly well. This is saying I took your main module with this Haskell source path of setup.hs, and I turned it into this object file. And
Mhm.
right, so like it needs to do that. Why I'm not an expert on why, but like this also would include any like template Haskell steps. right? So
Yeah.
um,
Yeah, because it's basically taking all the things you put in template Haskell and actually through the compilation things, it has to go through and compile it once and go, oh, there's all this template Haskell stuff. Oh, right, I need to take that and fill in the details from that. So he's going to have to go off and figure out what you meant by make one, and that filters into now your other module too. And so
yes.
he's going to have to do that a few times round probably to resolve all of the template Haskell parts, which that makes sense.
Yeah, and like
But
so,
yeah.
because it just to show here. Or I think I'm forgetting my. No, I want to do this. Oh, am I not in the right? So like I build like a .o file, and I'm like I kind of this is like kind of what showed me what I'm doing here. So like right we have turned this x.c into like a symbols file where we have add
Mhm.
and multiply as two symbols. Um, and actually,
Yeah.
I think we could also say um, and I think this would yeah. So like you know this is complaining or it's warning that we don't know where this came from. That's why we'd have like a header file, right? It is like to maybe it's coming from an external function or external module, and we want to define it that way. Um, but yeah, and then what I did too is I did main2.o, and then I tried to like link these two together. GCC. So main2 or main.o, main2.o, and it said like these two like I built so I took this source file, I turned it into two different object files, and so it
Mhm.
thinks that it has two declarations for multiply and add, and then I tried to
Yeah.
link them together, and this GCC is like calling LD. I think I can even do this with LD. Does that work? No. Yeah. Oh, this is LD. Um,
Yeah.
L- LD is just like the linker, and it just links together symbols, and like LD is used like everywhere. Um, and like LD is like even if you dig into like the Haskell source code, or it's like sorry GHC source code, it's using LD um, in its own fashion. Like it's calling LD at certain points in time, and so like when it was doing this, it was probably doing some linker step, or yeah,
Yeah, that makes
linking
sense.
setup. Yeah,
Yeah, because it's just given a different temp folder, hasn't it? Temp.40, temp.dir, temp.b, and then you say, like you say, it links it all together. That makes sense. Yeah, so it would have turned, yeah, made the objects because it's doing, but it's doing it from the same source code each time, isn't it?
yeah,
So my, it must be in some way. I think first doing it and going, oh, I've got unresolved template Haskell stuff. Then the second time doing it, going, okay, I've resolved some of those template Haskell stuff. And then third time, I think, okay, yeah, now I've resolved all of those template Haskell stuff at compile time. Because unlike all the rest of Haskell code, we have defined everything before it gets compiled. It's having to do some of that figuring out of what are the values and the types.
right.
Not just the values, sorry, the types at the compile time.
Right. It's kind of
Cool.
like
Yeah. Okay, that makes sense.
really like it's like we have like module one, right? The first build stage we can think of is like build module one. Then we have module two, right? And we're gonna build, and this is gonna create like some sort of you know like .o file, like let's call it 1.o or 1.o, and then that is going to be those symbols are going to be usable um, in context of module 2, right? And then module 2, oh, what the is going to get right, and we're going to have this like kind of recursive function of, now we have 2.0, and that can also be used for like 3.3.0.
Right.
You know,
Yeah. So yeah, it'll be taking the original file, but it'll also be taking the last output file as well and going, okay, yeah, now we'll compile it again, but with that new output file. Okay, that makes a lot more
Yeah.
sense. Yeah.
and,
Cool.
and so like template Haskell essentially has to like get down to like the linker, right? Like the template Haskell under the hood. This is all handled for us by GHC, but template Haskell has to deal with the linker, and so that's why we see like this example here, because there's with linking, there's like really static linking and then dynamic linking. Um, we probably like static linking, in the sense that like, I mean, you might not want it for the Raspberry Pi because, to my understanding, it's going to make a larger executable. Um,
Mm.
so like for example, on Linux you would have the symbol of I believe printf, um, to like uh, to print something to the terminal, um, and that's just a symbol that comes from some dot so. And so we can either bundle that in with our program, or we can have like a kind of stub in our linker code saying that uh, you know it printf exists, but we haven't proved that it exists yet. You know.
Yeah.
Um, yeah, we're assuming that like I guess, yeah, static makes less assumptions, and that we have like if we have successfully finished like the linking step, like if this step passed, then like we'll never have an undefined symbol. Whereas like
Yeah.
for a dynamically linked library, um, you know, we don't have that same guarantee. Um, and but yeah, but for for template Haskell, we need like full control over that. And even actually, the reason for this one specifically is because um, this actually goes. This is how I came across this cross compilation thing. Is that like, where is it? There's a third concept for a platform we call a target platform, and it says usually this is not this is rarely needed. We usually assume that the target is identical to the host, um, but um, this applies in the concept of template Haskell, because we still like any template Haskell generated code still needs to work on the target platform. So, for example, like when we build Android here, I have template Haskell code, and this has to make sure that template Haskell is not building for this environment, but building um, for Android,
Yeah.
which has like specific linker arguments and stuff.
Right.
Yeah.
Yeah. So that adds an extra level of complicate. Yeah, that's interesting.
Mm-hmm. Where is this?
But yeah, I mean, going back to the kind of the initial point, I think I don't know. Maybe if you're thinking about describing Nix, maybe just starting with like a really simple C project,
Yeah.
and then talking about that from that perspective, because then you can say, look, we need to, but maybe just spending a little bit more time on what is it, because I think I've seen it, and I've seen like that example before on on the thing, but it's like, well, what is a make step? Why do we do a make step? Why do we create this file? Why do we create an O file? What is that? I think there's maybe some context there that people
Totally.
might not necessarily understand. And then once you understand it for C, you can kind of say, well, when it's in Haskell, this is all actually done by GHC, so we don't need to think about it so much, or we need to think about it when it's about this, or and when it's Python, that's handled in a different way, which is an interpreted language, so it's a bit different entirely. But yeah,
Right. Right.
yeah.
Like exactly, because yeah, even then you get into Python, right? Python and JavaScript are like interpreted languages, and it's like a whole different thing. Oh, did I not? What the heck? Oh,
And then you got Java based, which is like Scala and Java, obviously itself, but they're running on JVM. So then you've got another thing, which is it's kind of like this bytecode running on a virtual machine type stuff, which is
yeah,
yet another somewhere between the two of interpreted and compiled.
yeah. Like yeah. I mean, and that's kind of what that's actually like for Android, you're running on your the main of your application has to be bytecode or JVM bytecode. Um, yeah, which I mean, those are really the three cases, right? You have fully compiled code. You have interpreted 100%, which is just an awful design to begin with. But, um, uh, you know, and then you have
I think it has its
bytecode.
I think it has its place. I think
I
like for
know.
like Bash scripts, you know what I mean? Like when you're running something really like, I mean, I agree to a certain extent with I think it was Senden who was saying, he loves Bash. I think Bash is great for what it is. But it's um I think people just started using scripting languages for everything, and it was like that was a bad option.
Yes.
I think everyone thought the processors would get so fast it wouldn't matter, but that's not happened.
Hmm.
There is that language, was it Mojo, which is trying to be basically Python but compiled and efficient. So
Oh, interesting. I mean, like
um,
everyone talks about Python's syntax being super simple, so that's like a good thing. I mean, Python's what I started with, so I can't say I hate it or whatever. That would be unfair. Um,
I don't hate it. I found I just found whenever I try to do anything more complex than just basically scripting,
yeah.
um, it just became very unwieldy very quickly.
Yes.
Thinking about what I was doing became more and more difficult.
Right.
And that's when I found Haskell and nice types.
Right.
So I don't when people say like, oh, it'd be like writing Python, I'd be like, that doesn't have no appeal for me.
Yeah. The,
But different strokes for different folks. Isn't
that
it?
that 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 in like summarizes too. I feel like why people start with like Python over Haskell is because like Haskell you don't realize it's a pain. Sorry, you don't realize that such a pain could exist of like not having types until you're too deep into Python, where it's like, oh,
Yeah.
like the Python syntax is so simple and easy to learn, and then you start with it and you're like, it's this
But
whole
I
thing.
think in a way that it's kind of a good thing. I think 'cause some people say, oh, you shouldn't learn Python first. I don't know. I think learning a scripting language first is good. I think, like, to be honest, learning Bash probably first. Put someone on a Linux machine. It's like, well, you want to do something on this Linux machine, you don't have to type the command in each time. Put it into a Bash script. That's where it first started. You know what I mean?
Right.
That's what that's kind of first things kind of started these things. It's like you don't want to write it. I mean, for me, it did anyway. I don't want to write this command every single time, or I want to put it on a timer.
Right.
So I put it in a Bash script. But then you find that Bash has this really anything as soon as you want to do anything over an array or anything more complex than very simple things, it
Right.
becomes very very unwieldy very very quickly. That's when I started looking at Python because it can handle arrays better, but it kind of gets you just one little notch above Bash, and but then you start running into these other issues. And I then had a very quick look at object oriented program and just went ugh. And then found Haskell when I was just playing around with window managers actually for Xmonad,
Oh,
and I was like, oh, this is nice. This is nice. Yeah.
I don't think I knew
Yeah.
that. That's how you came across Haskell, or I was like, I wish I had. Like I feel like our onboarding form, which very much needs updating. Um, it should ask like, how did you come across Haskell? Because that's interesting. That you just like kind of found it like by browsing.
Yeah, well,
You know.
I found one which was just like, yeah, so window managers. So like, you know how like how your windows are put on your screen. And then so it was when I was playing with Linux and I was going for like that, and basically trying to do the whole thing of going very simplistic and build it up. So I installed Arch, which you have to do all through commands, as it was no real installer back then when I first started playing with it.
Yeah.
So you have to kind of type in everything. So you kind of get an idea of actually what the Linux, not 100%, it's not Linux from scratch, but you do get a bit more of an idea of what Linux is when you're building it up by installing all the different parts. But you don't have a GUI. You have to install then GUI. You just got the command line, and so I build it up, and so I installed then different things. And I think the first window manager I tried was Python, but I forgot what it was called now, but I guess Pi something as it generally is. But it just didn't. It had some of the behaviors I didn't really like in that one. And then I was searching for a different one and saw a YouTube video and said, "Oh, Xmonad works this way." I was like, "Oh, that's exactly what I want." But obviously Xmonad was written in Haskell, and I was the first exposure to Haskell. I was like, that's just really nice because it's all very componentized. You've got this, as opposed to the sprawling kind of chasing what everything's doing down these different lines.
Yeah.
So this is lovely. And then set about learning it because I was like, this is such a nice language, and yeah, started actually building stuff unlike in Python, where anything beyond very simple scripts, I was kind of never really got anywhere with. So I was like, oh, love it.
a million like started projects and then like nothing finished or whatever.
Yeah,
Yeah.
exactly. Yeah, with Haskell got at least a lot further, at least like kind of things that you could say got to a particular stage as opposed to chasing whatever last error was
Right.
plaguing you.
Well, it's definitely a lot easier to just like make forward progress of some sort. Um,
Well, it's just so funny. You hear people talk about like the whole kind of agile stuff. Like, there's always that when you work in companies, is it agile, want initiative and things like that, and you're like, everything you keep saying is literally saying use Haskell because
Yes.
you can build a first thing and
Yeah.
then just say, do you like this thing to the client? And the client will go, yeah, I like that so far, but can you add this thing in? Okay, yeah. Add another module in, you set of components. Yeah, there'll be some amount of rewriting, but instead of like with like all the other languages, like I'm using Java at the moment, it's just like, can you just make this one small change and then the house of cards falls down and you spend your life chasing errors? And it's like, you just don't have that issue with Haskell. You can just do this nice. You could do the true agile, nice iterative process that people say they want, but very rarely actually do.
Right. In order to be agile, you need to be able to change easily. You need a language that can change easily, and that is types. And even like, I think what I'm trying to wrap my head around too, because I'm not a huge Java user. I don't think I've ever professionally used Java once. I used C# recently, which is very similar to Java. But even then, like we're using C# in like a functional manner, or as close to a functional manner as possible. But it's like interesting to me that like it would become so hard to change something in a typed language like Java. Like I don't I'm so curious as to like what like it must be like I'm imagining like the coding patterns are just what kind of makes it hard to change stuff or
Yeah, so it's the thing is if you're using a library and it's a library that you import because it's one of the libraries that's part of your your company, your code base you're working with, if that class, because the class has all the data structure and the functions inside of it, if you then want to add a new function to it, do you know what I mean? You can't just necessarily, you'd have to amend that library. And or if you want to add a new element to, I don't know, I'm trying to think of
oh I
it. Just
see like
it becomes so fragile when you want to actually change a piece, and then you change that one piece, and then it's not just the thing is just I don't know, it's just the types. I remember someone describing it as like the Java's types are everything that makes statically typed languages really difficult without any of the benefits of statically typed languages, which is a bit of an exaggeration, but it just there is an awkwardness you get with Haskell with having to make sure all the types line up. That is one of the things you just have to get past and learn how to embrace.
Yeah.
But once you get past that, you then get all this lovely benefit of it, which is largely that if then anything does blow up or you do change something, okay, that impacts that, I'll change that. Okay, that impacts that, I'll change that. Okay. And you can kind of follow it like a
Yeah.
domino. That makes sense. But with Java, it's like you make this change here, and then something over there blows up, and you don't know why that thing over there blew up when I made this change over here.
Right.
And and I don't really understand. I don't know enough about Java's inner workings of why that. But you often, when you ask someone, find, but they go, well, it's because of the way the Java runtime works. Is that it's taking this and it's doing this in this particular order, and you're
Yes.
like, oh, okay. So this seems to me from what these you can't from the code know exactly what changes I'm making here, how they will necessarily blow up in your face. Whereas with Haskell, it's all very in your face. If you make this change here, it's going to blow that up next. Then it'll blow
Yes.
that up next. It'll blow up that next. And the compiler therefore can tell you exactly what's
Right.
blown up and why it's blown up and all this. Whereas Java, there seems to be this kind of esoteric knowledge you need, which is what funny because everyone says Haskell's so esoteric. I don't think but Java, I find you seem to have this kind of just knowledge of just how it kind of works under the things. And just experience of solving those problems to get it to work. Whereas I think Haskell, you can just read it and understand. Do you know what I mean? I don't
Yeah.
know.
Interesting. No, makes
But
sense. Makes sense.
yeah,
It's kind of funny because I'm like I think of like job postings where they're like, oh, you need to know Java versus like saying you need to be a good programmer or whatever, and like there's obviously some validity to that. Um, you know, if you know Java, you know how to use Java and how to code in Java. Therefore, but yeah, like I had actually I had one interview that I had this AI that just applied to jobs for me for a while, um, and it got me into a Java role, and I went for the interview. I'm like, okay, whatever. I don't know Java, but like I can learn Java, and like the interview was like nothing but like questions about like how do you do this in Java, how do you do this in Java, and I kind of thought like that's silly, but because like again, you could just look this stuff up. Um, I mean, it was also strange. I'll say as an aside that they were an AI company that didn't believe in using ChatGPT, um, which is strange to me.
yeah.
Um, but yeah, like I guess I don't know. I can see how in Java it would just become like, oh, you need to have this understanding of the language or whatever, and I feel like that's just I don't know. It's a bad language design if like you can't like you need to have like that you can't just follow the compiler, like I mean the fact
Yeah,
that like I make this mistake or whatever, okay, I need to do something with this. Like this is actually all the errors I'm seeing now as a result of all the refactoring I did from Jenga. Right, I have a bunch of stuff that's like you can't load that or whatever. Like if I didn't have like I live off the errors from Haskell, I guess. So I think I see what you're saying now.
I think for me, it's just I think whoever said it, I forgot whoever said it, but the guy who invented null said it was the worst mistake he ever made, in his life,
Yeah.
and I completely agree with him. Null, Tony, someone's thrown it in there for me, Tony, or
Yeah.
yeah, I completely agree with him. Null is the worst thing because the thing is with null is that it doesn't necessarily always blow up
Right.
where it's been thrown. So you've got a null,
Yeah.
you get a null over here, and so in Haskell, therefore it would blow up over here. If you were saying it was supposed to be a value and it wasn't a value, you'd have to handle the fact it was a nothing.
Right.
Um,
It,
but Java it doesn't, and it can go through loads of different steps between where it's thrown that null and where it's actually going to blow up in your face. And that's what I think gives you this inherently kind of what I say, where I make a change and it starts blowing up somewhere randomly. And I was like, why is it blowing up over here?
yes.
And you just spend loads of time debugging, having to put loads of things, checking the value, you know what I mean? Doing all these
Right.
things. And it's just like things you just don't have to do in Haskell. So it
Right.
drives me insane.
And I think I forget always that like a Java or C# type language just has null. Like I'm like, well, it's statically typed, right? That's not like but that's such a like dynamically typed thing, or I don't know if there's a better proper word for it, but like the fact that you can just say, oh, it can also be implicitly a null in any case. That anything can be a null in any case is just like
Yeah, everything's a maybe, but you just don't. They don't. That's not typed.
yeah.
So everything at any point is a maybe. But also, I think, and I think Michael put something else in the chat. But effectively, everything is I/O. So like you know what I mean. Like again, you don't get this. So Lyle Haskell with I/O and laziness is much worse in terms of understanding the language. I don't know. I could not disagree that more. Laziness. Okay, I agree with laziness to a certain extent that it changes a bit of the flow. Like you don't necessarily uh, the flow of it happening, but I find that I just don't. I run into that issue very, very rarely. I've never. I don't really have a problem with IO at all. I, in fact, would say it's the exact opposite. I'd say IO makes Haskell so much nicer than Java because at any point Java can be off doing something, some sort of side effect. And again, this gives us what gives Java the whole. It can blow up in the middle of nowhere when I wasn't really
Mm.
expecting it to.
No, I
Do
think
you know
what
what
I
I
mean
mean?
is if you've written anything substantial like database handlers or like file processing, you never
Hmm.
know when IO has been evaluated. So you could be like running a program along and it's like ran out of bytes, and it's because something evaluated one thunk but didn't evaluate the rest of the lazy byte string. So it's really hard to reason about,
Okay.
first of all, what is actually in memory, and second, um, how much memory it's actually using. So if you're like dealing with pretty high um, what is it called? Things that are memory sensitive, right? So I write a lot of data infrastructure, like data frame stuff. That's typically a gotcha, and there's so many solutions, like 3 or 4 solutions, resource T, brackets, etc., and Haskell around the lazy IO problem. And the solution typically is just make everything strict, which ends up
Yeah.
defeating the purpose of the whole language. But I was going to say, I think Java's mistake isn't so much having null in the first place, because um, I think even a strongly typed language has a bottom type, like we have undefined.
Right.
But I think Java's
Mhm.
mistake, or most languages' mistake, is using that as a comparable value. So in Haskell, if you
Yeah.
give undefined back and you try and pass it into any other function, it'll just die. But like that would be the equivalent. The null pointer would be the equivalent of you saying you can return undefined, and then you can say, is this equal to undefined? And then continue execution. Whereas if you try and compare anything to undefined, if in itself, it just says, wait, this is a bottom value. Um, so I think it's not so much a failing of the type system; it's just more failing of like the denotational semantics of the language.
Maybe with when you were saying with the, and I don't know enough about the kind of the use case you're talking about with the database and stuff, but wouldn't could you not use something more along the lines of STM though and pulling off data into queues? Does that make sense? As a to create
It
that
still
order,
has to
because
be
whenever I
strict.
do,
So imagine you're reading
yeah.
like a 1 gig file and you have 3 gigs of
Mhm.
memory. At some stage, because of lazy IO, Haskell's gonna stop reading that file. Yeah, and
Mhm.
it'll read it like maybe about 200 megabytes, and then at some stage the garbage collector will like clean up the resource, or like the resource will be closed, and then you'll like think that everything is already in this stm variable or in a list, and then you'll try and iterate through the list, and then in the middle of iterating this to this list and creating this thunk, it'll try and generate the rest of the 500 gig megs of the list, and then it'll just die and be like, wait, resource error. And I think that happens a lot if you deal with IO and laziness in Haskell. At least I've talked to other package maintainers that do stuff like, you know, the database connectors and um, network stuff as well is a little bit strange. And you almost have to always force evaluate, which ends up being a little bit of an anti pattern.
Was that like a big challenge you ran into with like the data frame library?
Yeah.
Yeah,
Yeah.
makes sense. Um, Nick, for context, Michael's from Data Haskell, um, and built the data frame library, which I was looking into. I was looking into the tutorial. I read through the tutorial yesterday. Gotta say, it's been a while since I've even done like data analysis. Like I did like that's kind of what I started programming with like 7 years ago, um, and I haven't really picked it up since then. But it was a pretty like good tutorial. Um, it, did I read correctly that it's like not finished, or like, cause it looked like it was done or like ready to go, or um, yeah.
Uh, the things that aren't finished are kind of pie in this, not pie in the sky. So, um, processing files larger than memory and doing a kind of MapReduce thing where you read a file, spill it to disk, and then you do group bys and joins. And then the other thing is, um, oh yeah, a couple of window functions in the SQL world. And then the last thing would be integrating with like some of the big database connectors like DuckDB, Apache Arrow, and Parquet. A lot of file formatting stuff, but I think the core design is mostly done.
Cool, cool.
I, I think the
Go ahead, go ahead.
Sorry, no, I was going to go back into what we were talking about before. Sorry, so, but I was going to say, I think I would say though that the difference there is I can understand if you're building libraries around, like you're saying, around networking or database handling, that the issues you're talking about could definitely be really really tricky to handle. But as someone who's maybe not working at that level of those libraries, if you know what I mean, um, that's kind of almost a black box for me, if you know what I mean. So whereas with Java, I feel like even just as a kind of fairly basic developer doing basic things, these problems kind of can proliferate. Do you know what I mean? Whereas there's more of a like kind of a clean edge with those problems. Once the library's created, it's less of an issue. I'll push back on that if you think that's wrong, Michael, please.
It depends. How much do you work with web dev? Because that's a lot of like open this file, persist this JSON, read this database, send it through the network. That seems to be the bread and butter of most programming.
True. I mean, most of what I'm doing is just really just APIs, just really just things
I
being
see.
called and passed through. So I think from my perspective, it would seem much more simple to use Haskell for that, but I could be wrong still.
I see. I see. So I've done some stuff full stack with both Servant and Yesod. Yesod. I don't know how to pronounce it. And the kind of resource problem does come up a lot. But Michael Snoyman, as part of Yesod, thought really hard about the problem of how to handle resources, and I think he's the one that ultimately made the resource T pattern to be like, oh, let's make a monad that has the resource, and it'll never let it go until you get out of the context of that monad. But before that, I think it was a much harder problem. And if you kind of do I/O in the wild, like get file or like get line, etc., or put string in line, for file handles, it becomes a little bit difficult, even for very small toy problems.
Okay, that's
Mm.
really interesting. Well, I'm definitely going to look at resource T then, if that seems to be the best solution. That's really useful. Thanks, Michael.
Yeah, I know. Even actually, like with the first project that we do, like the very simple command line app, where like I kind of was telling people just like make it a file, just keep your to dos in a file, so that it's just easy to get started on the project, and it would a lot of the time be like a weird error of like the file is busy, um, even though like the I guess I was surprised by the error, that you would write to the file and then like immediately try to read from it, um, and it would be like the file is busy. So maybe that's a different thing now that I say it out loud, but um, I don't know. There's definitely been some like kind of weird errors that I've seen with IO. I apologize. I do need to run. You guys are welcome to stay on the call, but I do need to run. So, great discussion. Um, talk soon.
Thanks.
Yeah, good
Yeah,
volume,
That was
guys.
brilliant. Thank you.
I'll be at Pi Data conference out here in Seattle, trying to convince Python people to jump to Haskell.
Heck yeah. And
Cool.
that's happening right now, or like this weekend, or
Yeah, it's a 3 day conference. It started yesterday, and today is the lightning talk on the data frame library. Actually,
on your data frame library.
yeah,
Yeah. Okay. Cool. Cool. I wasn't sure if it was like the Pi. Well, I guess it's not called data frame. It's Pi pandas or whatever. But awesome. Yeah. Is there going to be a YouTube recording?
I'll have to check.
Fair enough.
I'm not sure.
Fair enough. All right, guys. Peace out.
Cheers.
Cheers.